Hello and welcome everyone. Thanks for joining us for this O'Reilly Media Live course. I'm Ellen Evans and I'll be your facilitator for today's course. We're excited to have you here. We'll be kicking things off shortly, but before we dive into today's content, I'd like to go over a few housekeeping items to help you get the most out of today's session. At the top right corner of your screen, you'll see a set of widgets. The tool we'll be using most today are the Q&A and attendee chat. Feel free to open those up now as they did not automatically open when you first joined. We encourage you to jump into the chat and be a part of the conversation. This session is being recorded, including any participation from attendees. So if you take part via chat or Q&A, please do not post anything personal, such as your email address, because that will be included in the recording. Please note that the chat feature should not be used if you're subject to related communication restrictions. Also, keep in mind that others in the audience today may include fellow professionals, vendors, or even competitors. We hope you'll take advantage of the interactive tools, but please be cautious about what you choose to share. You'll receive an email within the next 24 to 48 hours with a link to the session recording so you can review or catch up on anything that you missed. You can complete the feedback survey anytime by clicking more in the top right corner of your screen. It'll also pop up automatically at the end of today's session. We'd love to hear your thoughts and thanks for sharing your feedback. And with that, let's get started. I'm going to hand things over to Janani Ravi to kick off today's course. Thank you.
Thank you, Ellen. Hi, everyone. Welcome to this training. My name is Janani, and I'll be your instructor for today. Uh, I'll do a 30-second intro. I've been a software engineer, I think now for 25 years, and I've been working in data for, I don't know, 10, 15 years. And Snowflake is one of my favorite platforms. So, aside from work, I have 4 dogs, so I'm a major dog lover. Oh, professional career. I did my master's from Stanford and I worked at companies like Microsoft, Google, and then I kind of branched off and I do my own thing now. So, all right, let's get started. Now, this is a 4 hour course, and I know 4 hours is a long time for you to be concentrating. So, I'll make sure that at the top of every hour, you get like a 5 minute break. So, every hour, we'll have a 5 minute break. Now, I'm going to be talking for 4 hours, and I know you guys can't talk back to me. And it's talking into the void is hard because it's hard for me to tell whether you understood what I'm saying, if everything is going well, it's going badly. So my request to you is please, please, please use every 10-15 minutes I'll ask you, so how are things going? Do you have any questions? Just use the emoticons to kind of express how you feel. You can use any happy emoticon if everything is going well, like thumbs up, happy face. And if it's a thumbs down or a sad face for a reason, please ask me a question. So give me a chance to kind of explain things in a different way if that would help you. So with that, let's get started. I'm going to share my screen and I'm going to present my slides using this screen share. So you should be able to see my screen in about 3 seconds. Yeah, you should be able to see my screen now. Oh, and by the way, if you want to ask me questions, you can use the Q&A widget. I look at that less often. You can use the attendee chat. I'm constantly monitoring that, right? The recording will be available within 24 hours. Yeah. So if you can't download content from GitHub, see, the thing is, I used to put it on Google Drive and we couldn't download content from there, and that's why I put it on GitHub. My recommendation is you don't need that content right now as we are doing this course. In the sense, I'll be doing demos, but I think it'll be best if you just kind of follow along with what I'm doing without actually doing things yourself, and go back, watch the recording, get yourself signed up for a free trial, and then try to do the demos the second time, right? I think that's the best way to get the most out of this learning. So I hope that makes sense. All right. Now, I'm going to be presenting slides. I'm going to have a huge number of demos. So about 65% will be hands-on in this course, maybe even more, right? But you do need some concepts so that you understand what's going on. Right? I'm logged into Snowflake. I'll show you how I got to this page when we do the demos. And here is my GitHub link. And since many more people have joined, this is the GitHub link, which contains all of the resources for this course, right? So all of the data sets that I use will be in this data sets folder. SH files, they're not actually scripts. They're handwritten notes telling you where you go and how you can what button you press, etc., to do the demos that exactly the way I'm doing it, right? And I have 14 demos here. We won't be able to get to all of these. I'll tell you that up front. We'll do the most important demos, but likely we won't get to common table expressions or window functions. Those are much more SQL demos. I just want to show you that they are possible in Snowflake. But I'll try to do as much of the others as possible. Right? With that, let's get started. Snowflake, what are the prereqs for this course? I'm going to be writing many SQL queries, so you should have a basic understanding of SQL. So if you don't know any SQL, it will be a little challenging to follow along. But SQL is so simple that you should still be able to, learn something. And some familiarity working with the cloud will help, though that's not an absolute requirement. Okay. Uh, if you want to be able to do the demos on your own, you can sign up for a free Snowflake account at this link here. And this is the GitHub link for the resources, the one that I've pasted into the chat window. Right? Once I get to the demos, before I actually start the demos, I'll show you how you can go to the sign up link and sign up. I'll show you the details of that. So I won't leave you hanging. But you need a free trial account. Snowflake has an incredibly generous free trial. So the free trial runs for 30 days. You can sign up with an email address and you get access to basically most all introductory features for sure, but many advanced features as well. So I feel Snowflake has one of the best and most generous free trials of all the different data platforms out there. All right, I'm going to push out a poll question just to get to know you guys before we get started. The poll widget now is a good time for all of you, everyone who's joined this class, and there are many of you here, to find the poll widget. It'll be hidden behind the media player, embedded within the slides widget. So I have a poll widget for you. Okay. The first of you, one person has found the poll widget. That's awesome. And if you can't find it, I would suggest post a question on attendee chat. Someone will help you out with it. Okay, a bunch of people. Okay, many of you have found the poll widget. Say about 10% of the class. Okay, so I see thumbs ups. That means you guys have found the poll widget. Exactly. Thank you, Ellen. Ellen has very clear instructions on where the poll widget sometimes tends to hide. Okay. Awesome. I'm super excited about this class. And anyone who's joining right now, you haven't missed anything yet. I've just pushed out a poll. I've said the only prereq you need is SQL. And I've sent a link for the GitHub repository that contains the resources for this course. All right, I'm going to take a look at what you guys said. Most of you are very comfortable with SQL queries. That's awesome. Another quick question, just working on cloud platforms, how much experience do you guys have? One more poll, and then it'll be all content, and the remaining polls will all be about the content. One more poll to get to know you guys. I'll just wait 5 more seconds. Okay, let's take a look. You should be able to see something 80, no experience, somewhat comfortable, very comfortable. Kind of evenly split. I think most of you are somewhat comfortable, and that's more than sufficient. And if you have no experience, it doesn't matter. Snowflake is so simple, you don't realize there's nothing special you have to do. Right? Okay, let's talk about what exactly Snowflake is all about. And I'm curious whether you guys have worked on Snowflake before. Right? There's a lot of background noise on my mic. Is it? Uh, I'm trying to figure out what it is before. Let me, is that better? Is that better, TA? I always try to debug background noise because different times, different people hear noise for different reasons. So move the mic. Okay. Yeah. All right. So let's get started. How many of you have worked on Snowflake, and what kind of experience do you have? You can just write in chat while I explain what's going on. Right? So, what is Snowflake? Snowflake is a super easy way for you to work with data. Write SQL queries on data, perform complex analysis on data. You can build and train machine learning models. You can build dashboards. You can perform write ELT pipelines, right? You can write ELT pipelines. You can write complex event driven tasks, right? You can do all of this in a very very simple way. Now Snowflake allows you to programmatically access your code using Python and other programming languages, but basically in this introductory Snowflake class we're not going to write any Python, right? Yeah, we are only going to be using SQL queries to work with data, and Snowflake allows you to do a lot with SQL queries. So clearly, all of you are newbies. At least those who have responded are newbies to Snowflake. BT seems to have worked for some time, so BT, you should share your experience. Okay, yeah, okay. So anyone who's worked on Snowflake, please do share your experience. It'll be useful to me and to anyone else who's attending this course. Okay? And if you have no experience, you're in the right place. Now, here's the definition for Snowflake. It's a cloud native software as a service advanced data platform, okay, which allows you to store, process, and analyze data. So that part is clear. What does it mean to be cloud native? Right? Snowflake runs only on the cloud. You can't install Snowflake on premises. That's the whole idea with Snowflake. It runs only on the cloud, right? It's software as a service, meaning it's just available for you to use. You can write your queries on top of Snowflake. You can build your applications on top of Snowflake. You don't have to manage any infrastructure. You'll basically see that you're abstracted away from all of the infrastructure when you work with Snowflake. So cloud native software as a service, right? FR, if you've worked with Snowflake for 2 years, this might seem like a very introductory course for you, right? Just a heads up. So, uh, but maybe I hope you learn something new. So, okay. So, what does it mean to have a data platform as a cloud service? With Snowflake, there is no hardware to set up, install, configure, or manage. We just log in and upload our data and start writing queries. You don't have to worry about software. You are not responsible for upgrades, right? You're not responsible for configuration, nothing. Right? You're not responsible for security, you're not responsible for patching. Snowflake takes care of that. Okay? So administration, maintenance, upgrades, everything taken care of by Snowflake. Okay? Snowflake runs on the public cloud. So if you call up Snowflake and say, you know what, I have my on-premises data center, I need you to install Snowflake there, that won't work. Right? Snowflake offers isolated environments where if you have very critical needs, you can run Snowflake in an isolated way. Okay. Uh, but it basically runs on the public cloud. So Google, Azure, AWS. These are the clouds that Snowflake runs on. Okay? So under the hood, what Snowflake does is it makes use of virtual machines and cloud storage on these cloud platforms for persistent storage. But we are completely abstracted away from all of that. We just store data in Snowflake, and we know that data is stored in an optimal way, and we just pay for Snowflake, right? So users cannot set up Snowflake on private on-premises clusters. Okay? Now, Snowflake has a very, very powerful SQL engine, but it does not make use of any existing database technology. So it's not running MySQL, it's not running Postgres, it's not running SQL Server, right? It's not running any of the big data technologies that we are familiar with, like the open source ones, Hadoop or Spark, right? It doesn't use any big data framework. It has its own proprietary SQL engine, and it has its own unique architecture, which is basically meant to run on the cloud. So it makes use of the elastic nature of the cloud. So where does Snowflake run? Public cloud, right? Uh, Snowflake is Snowflake supports all three major cloud platforms. Maybe in the future, who knows, right? If Oracle Cloud, IBM Cloud catch on, Snowflake will start running on those clouds as well. But right now, they run on the big three. Okay. So in every cloud platform, there are some regions where runs. So Snowflake doesn't. So every cloud platform has regions in the world where they have their data centers, right? East coast of the US, central US, west US, Eastern Europe, Northern Asia, Australia, and so on, right? So on every platform, Snowflake will have certain regions where Snowflake accounts can be provisioned. Okay? So typically, the way you maybe you're already using some cloud platform. So maybe all of you are maybe your organization is using AWS. What you'll do is you'll see, okay, all my data on AWS is in the east coast of the US. So let me provision a Snowflake account in the east coast of the US, and then get my data into Snowflake and work with Snowflake on US East. This is how generally the decision is made. Okay. Now, Snowflake is made up of three major components. Three. By the way, this is all very introductory, so I'm kind of going through it quickly. But if I'm going too fast or going too slow, please let me know. Okay. Since this is fairly basic, right? And I'm sure this is just like warming up for you guys. Okay. Snowflake's architecture is made up of three main components. First is where the data is stored, right? That is the storage layer. Next is the compute where the query is processed, right? And the third is cloud services, which takes care of everything else, right? Other than storage and compute, there's like managing metadata, managing security, making sure governance is set up correctly. So everything other than compute and storage is taken care of by the cloud services component. Okay? And this is what Snowflake's architecture looks like. At the very bottom layer, we have database storage, where data is stored in a very optimal compressed format. Okay? Query, query processing is done via something known as virtual warehouses. Okay? Please do not confuse them with data warehouses. I kind of feel virtual warehouses, maybe not very well named, but now I'm used to it. Right? Virtual warehouses are the compute clusters where your query is processed. Right? Once the query plan is made, your query is executed on these virtual warehouses. Okay? So database storage contains the data, virtual warehouses, compute clusters that run your queries, cloud services, everything else, right? Authentication, access control, optimizer, optimizing your queries, making up the query plan, metadata manager, security, infrastructure manager, all of those belong to cloud services. Okay? Uh, so database storage, let's talk about that first. Okay? Database storage is where you store whatever data you're loading into Snowflake, right? Typically with Snowflake, you'll work with structured or semi-structured data, right? Like JSON data or tabular data. Okay? And these will be huge data sets. So remember, the whole idea of Snowflake is to work with big data. So it's not a database, it's more like a data warehouse. So you don't get acid properties, right? Atomicity, consistency, isolation, and durability, but you have the ability to run analytics on huge data sets. Okay. So Snowflake uses its own proprietary internal format to store data. Okay. So Snowflake's format is its own. They don't tell you what that format is. They just tell you, oh, it's proprietary internal, but it's a columnar format. Data is compressed. If you don't know what columnar format means, please hold on. I'll explain. I think the next slide explains that. Okay. So the data is stored in a columnar format, which is pretty standard for all huge data sets. Okay. It's stored compressed and it's optimized so that your queries run quickly. Okay. The storage layer basically manages all aspects of data, how the data is organized, the statistics, backups of data. Okay? Now, the thing is, the storage layer, this is typically run on cloud storage, right? It's typically run on cloud storage on whether it's AWS or Azure or Google, right? You cannot access that storage layer directly. So you can't go muck with their compressed format. However, you can of course use Snowflake's interface to access your data, and that's the whole point, right? You're not supposed to be able to access your data directly. So, so what is columnar storage? Now, to understand that, let's understand what row storage is. Okay? Row storage is you have a normal tabular layout. First, the first record is stored. Okay? Then immediately in the contiguous memory location, the second record is stored. Then the third record is stored, and so on. Okay? So with row storage, every row is stored together, and data of different types is laid out in memory. Okay, so this is low storage. Now, column storage is a little different. Now, row storage is totally fine if your data sets are fairly small. Okay, if your data sets are small, row storage is good. But for large data sets, you want to store in a columnar format. So row storage is great for looking up single records, but it's very bad for analytical processes because let's say I only want to aggregate the quantity, like find the average quantity. I'll still have to read product and warehouse. I'll still have to read the other columns because I have to read everything row wise. So with analytics processing, you typically access a few columns of data and perform some kind of operation on them. Right? That's standard analytics processing with SQL or even without SQL. Right? So row storage does not work well for analytical processing, and that's where you use columnar storage. With columnar storage, you basically get your columns are stored in contiguous memory locations. So first, all of the products will be stored, then all of the quantities, and then all of the warehouses. Now, what's the advantage of this? With columnar storage, every value in a column is of the same data type, right? Is of the same data type. Now, if it's of the same data type, compression is easier. Okay? So columnar storage makes it easy to compress and query data, and all data warehouses today store data in columnar storage. Okay? So if you're thinking about a BigQuery, right? Google's BigQuery is a competitor of Snowflake. They store their data in a columnar format. Databricks' Delta tables, they store their data in a columnar format. So everyone stores their data in a columnar format. So with a columnar format, you know processes are very efficient at scanning individual columns, okay? And it's very good when you just want to access a few fields and perform some aggregations on them. Okay. So quick look at query processing. Query processing is done. So the query processing layer is different. So your storage layer does not do any query processing. So this is important. Okay? Query processing is done via virtual warehouses. Okay, virtual warehouses. So the processing layer makes use of virtual warehouses where a warehouse is just a cluster of machines, right? It's a fancy term, it's a term Snowflake uses, but think of a warehouse as a compute cluster. Okay, so warehouses will have one or more compute nodes. Every virtual warehouse is an independent compute cluster. So they have their own resources. So if you have virtual warehouse A and virtual warehouse B, they have their own separate compute resources. Now, if you have two queries running, one on warehouse A and one on warehouse B, they are not competing for resources. They are not competing for resources. However, if both queries run on the same virtual warehouse, they are competing for resources. They are competing for resources. So this is important for you to understand. Okay. So MS has a question. If we have a columnar format, how will we identify um, which values for which product? They have metadata for that. That's the thing. When you store it in a columnar format, you store all this metadata so you can get the records for a particular row. Right? It'll have some indexing metadata. So we don't have to worry about that. That is Snowflake's problem. Okay? There was a question here: what is the IT market share for Snowflake? I can tell you that Snowflake is one of the most popular, if not the most popular. I can look this up for you to see whether Snowflake is The thing is, I don't know which site you would prefer. So, as far as I can tell, you can say Snowflake is in the top three. I feel comfortable saying this. Okay, Snowflake is in the top three. I feel very comfortable saying this. Whether it's number one, I'll have to look that up. Okay? All right. So let's talk about the cloud services layer. This is pretty straightforward. Any processing that you do besides compute and storage, it's all about coordinating activities, right? That's cloud services. So cloud services also run on some compute instances, right? They also need servers to run, but we can't see them, we can't interact with them directly, right? And similarly, we never interact with compute clusters directly. We only work with virtual warehouses, which completely abstract away all of the compute stuff from us. So we are abstracted from the infrastructure. How do you interact with Snowflake? You have a user interface, right? Which is what we'll use for 90% of this course. There is a command line client called SnowSQL, which is what we'll use for 10% of this course. You can connect to Snowflake via ODBC and JDBC drivers, so you can install your own client and get the URLs and connect. You can run Python and Spark code via connectors and connect to Snowflake. Okay? And there are third-party connectors for business intelligence tools and ETL pipelines. Okay? Please explain differences in processing data in row and columnar storage. See, when you, it's the differences in how you read data. Processing data, once you read data into memory, the processing happens in memory, right? So the difference is in how you read data, and in columnar storage, you can see typically for analytics operations, you're not going to access a single row. Right? For analytics operations, you're going to perform aggregations on columns. So you select a few columns and run some average or sum or group and aggregate on them. Now, columnar storage reads column data very, very efficiently. Row storage reads individual records efficiently. That's the difference. SB, let me know if that made sense. Is the cloud service used for each layer different, or the warehouses are different? How are compute and storage separate? Okay. Compute and storage are just different layers, right? We can't see them. We can't see them. This architecture diagram is kind of what happens behind the scenes, right? This architecture diagram is what happens behind the scenes. Okay? You will actually set up virtual warehouses, right? When we come to the demos, you will set up virtual warehouses. Okay? Cloud services, it's all again what's happening in the background. We never configure anything in cloud services. Okay? Of course, we can set up users and so on to access Snowflake, but that just happens. That's just taken care of by the cloud services layer. You should know it's a separate layer. Beyond that, you don't have to worry about it. That's in response to you, AN. Please let me know if that answered your question. Okay. Quickly again, Snowflake has 4 editions: standard, enterprise, business critical, virtual private Snowflake. Each edition has more and more to offer. Okay? Our demos will be done using the enterprise edition. Quickly, let's see how the editions are different. Again, this is all just big picture, right? This is, you should know what product you're using, right? At least at least some idea of the various aspects of the product. Okay. Standard edition, basically that's the bare minimum introductory offering. You get data encryption, you get time travel up to 1 day. Time travel is the ability to access data from the past. Okay. So access the state of your table as it was in the past. And we have a demo on time travel, you'll understand that better. Okay. Uh, Disaster recovery with fail safe up to 7 days. If you don't know what they mean, don't worry. I'll discuss them in more detail in a bit. Basically, this is the plain vanilla edition, bare minimum. Okay, bare minimum. You don't have these multi-cluster warehouses to run, many queries concurrently. Okay. If you're a government organization, you'll never use the standard edition. Even businesses will not use standard edition. Okay. Enterprise edition is best for small and medium businesses. Okay. Gives you more additional time travel, more security configurations, but it does not have the regulatory and compliance requirements, right, that governments might need. And then business critical edition. So governments, financial organizations, healthcare organizations will use business critical. Basically, no, they won't use this. Sorry, they'll use virtual private Snowflake. But if you're a large organization, you'll use business critical. So you get a lot of like disaster recovery, high levels of data protection, but your Snowflake will run on infrastructure that will be shared with other tenants. So if you have very sensitive data, especially like in the healthcare industry, you may not want business critical. Okay. So business critical has the highest level of security that a regular organization might want. But if you're a financial organization dealing with money matters, if you're a healthcare organization dealing with people's health records, you'll go with virtual private Snowflake. Okay. Virtual private Snowflake gives you the highest level of security. Basically, what Snowflake does, it makes sure that whatever machines your Snowflake account is using, no other company is using those machines. So your data cannot leak, right? There's an additional, not cannot leak, but the chances of your data leaking are very, very small. Okay. Does one Snowflake account use only one S3 bucket? NJ, the answer is I don't know, right? But not necessarily. But not necessarily. This is all Snowflake's internal architecture. Whether they use one bucket, whether they use multiple buckets, what kind of replication do they use, how do they ensure there's no throttling, how do they ensure throughput, that is hidden, that is Snowflake's proprietary stuff. Okay? That is Snowflake's proprietary stuff. And really, that's not something we need to worry about when we work with Snowflake. Okay? PP, the answer to what you asked is yes. He says, can we read time travel to read old versions like delta tables in Databricks? And the answer is yes. We'll have a demo on that. Okay. So how do you pay for Snowflake? With Snowflake, you have storage, compute, and cloud services. These are the three layers. Okay. Your The way you pay for Snowflake is determined by something known as Snowflake credits. Snowflake credits. Okay. So when you're using resources, when you're using storage, when you're using compute to run your queries, you pay for those resources using credits. Now, how much a Snowflake credit costs, that depends on which cloud platform you're on, which region you're working in. And in I'll just kind of show you how to sign up for the free Snowflake account in about 2 minutes, and Snowflake credits will become much clearer. Okay. So this is for storage, you pay a rate per terabyte for your live data, including any backups. Okay. So average storage used per month after compression. So your data is compressed in Snowflake. You don't pay for the uncompressed storage you might use. You only pay for the compressed data storage that your data uses. Okay. Compute is what you need. The virtual warehouses that you run, those are going to cost money. uh, you pay for the warehouses only when they are running and when they are processing queries. So only when the warehouses are running do you pay for the warehouses. If the warehouses are in a suspended state, you do not pay for them. Okay. And any all the management and coordination, there is an additional compute charge. That's kind of you don't really it is let's put it this way, they are not as transparent about the cloud services charge. Okay. All right. If you transfer data in and out of Snowflake, you pay additional charges. That's again something to keep in mind. So remember, data transfer charges you pay for separately. All right, let's do a quick poll. And after this poll, I'll quickly show you how you can sign up for a Snowflake free trial account. I have two poll questions for you. Simple poll. Those of you who joined a little later, the poll widget is in the slides player and it could be hidden behind the screen share media player. I'll wait 5 more seconds. All right, let's take a look. And virtual warehouse is absolutely correct. Cloud services that handles authentication and metadata. Data storage does not do any processing. The processing engine runs on the virtual warehouse. Processing engine is just a generic term. Okay. One more poll. There's a question here. Snowflake, just like other platforms, does not charge for putting data into Snowflake. So no charges for ingress, charges for egress. AK, can I request you to please use the poll widget? See, if you respond on chat, either you're right or you're wrong. If you're right, you're giving the answer away. And if you're wrong, then you're misleading the others. So maybe just take a moment to find the poll widget. MV, SB, the same for you guys. Just take a moment to find the poll widget. Uh, all right, let's take a look. And virtual private Snowflake is correct. Absolutely right. Snowflake charges for ingress, does not charge for egress PS. All right, let's just quickly see how you'd sign up for Snowflake. Right? A little boring looking at slides all the time. Right? Let me show you how Snowflake pricing works so you'll understand how credits work. Okay. So this is the URL that I went to. This is the URL that I went to. Okay. And here you can see Snowflake pricing. We have standard, enterprise, business critical, and virtual private Snowflake. Okay, now I don't have to register for this. Okay. Notice that Snowflake supports AWS, Azure, or GCP. So based on what cloud platform you're using within your org, just pick the right one. Right? Within AWS, these are the regions supported. Okay, these are the regions supported. So you can see there are regions in North America, Asia, Europe. Right? Then, then you can switch to Azure, and these are the regions supported in Azure. And Google has the least support from Snowflake, right? But still, at least regions spread out reasonably across the world. Yeah. Let's go back to Azure. Now, the cost of one credit is different if you are in different editions. So if you're in the standard edition, one credit costs just $2. Okay? If you're in the enterprise edition, one credit is $3. This is on Azure. It will be slightly different for AWS. Right? I guess not. It's 234 for all. Yeah, it's 234 for all. Right? And if you're in the business credit critical edition, you get your one credit costs $4. Okay, so you can see here that credits. So basically, whenever you look at the cost of anything within Snowflake, especially for virtual warehouses, okay, it'll all be in terms of credits. How much a credit costs depends on what edition you're using and what region you're using. So I'm now going to switch to Korea. You can see credits are a little different. They are more expensive in Korea as compared with US, Virginia, right? If I go to Central India, my credits are okay. They are not that expensive. They are the same. But Japan East will be more expensive. Okay. So the credits depend on what edition you're using and what region you're running and what cloud platform you're on. The combination of the three. Okay, exactly, CH. Exactly, CH. Okay. So HR couldn't see the poll. Next time, if you can't see the poll, please post on chat and we'll we'll get you set up. All right. So the way I signed up for a free trial is I went to enterprise. So I chose Azure, and I think actually I can't remember what region I chose. So let's say I took East US, right? I just clicked on get started, okay, and it basically takes me to the Snowflake 30-day free trial page. And like I said, it's very very generous. Okay, it's very very generous, and you get $400 worth of free credits. And seriously, like our demos will cost say $10 to $15, not more than that, right? And you have $400 of free credits. So a couple of questions. Cost varies based on regions. Why is there a difference? Even on regular cloud platforms, you'll find that even if you instantiate a virtual machine, cost will differ based on regions because it depends on how expensive it is to run a data center in that region. So the electricity costs in that region, land costs, manpower costs, everything feeds into the cost of infrastructure. Right? So think it's like data centers. There's a large real estate angle involved, right, and power angle involved. If we start virtual warehouses, is it a cold start? Hmm. See, when you talk about virtual warehouses for processing queries, the term cold start slightly. Um, I have not heard it used in that term, but I understand what you mean. So it's a very sensible question. Basically, virtual warehouses cache data. The data cached is not lost when you restart warehouses, but essentially it runs processes from scratch. It doesn't pre-process data and keep, but it does do caching. Okay? I hope that answered your question. Okay. Now I'll just log into our Snowflake account. I'll show you how I logged in. Okay. Basically, I have a URL for my Snowflake account. I'll show you what the URL looks like. So what I did was I just signed up for this free trial, okay, with an email address. It says work email, but you can use Gmail addresses as well. Okay. Then after you sign up for a Snowflake account, it will send you an email and it will give you steps to activate your account. And once it gives you steps to activate your account, it will give you a URL like this. Okay. And you type in that URL, it will ask you for your username and password, which you would have set when you activated your account. And once you log in, this is the page that you'll see. This is the page that you see. I set up the account 2 or 3 days ago to kind of run through the demos to make sure everything still made sense, and I kind of tweaked my demos a bit, right? You can see I started with $400 and 30 days, and I have $386 left and 27 days left in my free trial. Okay. So this is the main Snowflake UI. The main Snowflake UI. Okay. We'll just quickly just go through this UI and then I'll go back to theory because there's a bunch of theory that you need to understand, right? So worksheets are where we are going to write SQL queries. So you can set up notebooks to work with SQL. So you can write Python code and R code in notebooks. We're not going to be doing that. Streamlit is an easy way to build applications on top of your Snowflake data. Okay? You can set up dashboards, and these are all workspaces for collaborative working. You don't need to worry about this. Okay? But I'll show you how you can set up a worksheet. Okay? You can say plus SQL worksheet, and this is where you write SQL queries. Okay? And you can rename your worksheet. I'm going to call it queries. We'll come back to it. Okay? Now, ingestion is all about how you add data to Snowflake. Okay? There are many ways to get data into Snowflake. I'll show you a couple. We'll first upload data and then we'll upload data from stages. Okay. Transformation is how you build ELT pipelines in Snowflake. So extract, load, transform pipelines in Snowflake. We'll do a demo on dynamic tables. Snowflake has lots of cool new features on AI and ML. Again, not part of this course because this is a little advanced, right? But this is where you access them. You're monitoring, where you look at what the history of queries that you've run. I ran a few queries today. You see the queries that I ran over the last 3 days while I was looking at this course. Which queries succeeded, which queries failed. Okay. Catalog is where you access all of your databases. I have a test database that I set up earlier today. Okay. Sharing is, if you have data, you can make it available to other Snowflake customers. Governance and security is where you'll set up, all of the administration. You'll set up users and you'll create groups. You'll give them the right permissions. Compute is where you set up your virtual warehouses. Okay. And when you first log into Snowflake, it automatically creates a warehouse called virtual warehouse. Now, when I say warehouse, I mean virtual warehouse. Okay. It will automatically create a virtual warehouse called Snowflake Learning Warehouse and another Streamlit specific warehouse. Okay. So it automatically sets up. Notice that its status is suspended. So right now, I'm not paying for these warehouses. I'm not paying for these warehouses. They're suspended. Okay. Admin here is where you can kind of look at your billing and do cost management. Okay. So you have to have a, so you can select a particular warehouse and then you'll see like the spend in currency. So you can see across warehouses how much money I have spent. I will create this data load warehouse. I've already spent $2 on this. Some cost insights, which queries were the most expensive. It's kind of giving you a big picture, this cost management. Then there's billing. Right? I don't have to. Oh, another cool thing about Snowflake's free trial, you don't need to specify a credit card. And I actually feel this is an important reason that Snowflake is such a leader in the warehouse market. They make trying Snowflake out so easy. Okay. All right. Let's quickly go back and understand virtual warehouses. This is an important concept. Now, notice in Snowflake's architecture, the storage layer and the processing layer are both separate. So they're independent storage and compute. Now, this is extremely important. This is extremely important to have independent storage and compute. Why is that? Right? Now, you might have a huge amount of data. Okay. Or sorry, you may have less data and then you have many people running queries, many users, thousands of users. Okay. In that case, you can simply scale compute. You can add more virtual warehouses. You can set up multi-cluster virtual warehouses, right? So you scale compute, but your storage still remains fairly limited. And PG, the answer to your question is yes. Okay. Or if you have a lot of data, you can scale storage, but have just a few virtual warehouses. Let's say you have just four people running queries, but you have a lot of data to analyze, right? So in such situations, you scale your storage layer, but you won't scale compute. You won't add more virtual warehouses, right? So this independence of storage and compute is extremely important, and this is actually one of the cool things about Snowflake. The thing is, this is now available across all warehousing platforms. Like BigQuery has it, right? All of these warehousing platforms have it. Okay. A virtual warehouse is just a cluster of compute resources. Compute resources, what are they? CPU, memory, storage, temporary storage, which to perform operations on Snowflake. What operations will you perform? Query processing, right? And if you're running Python, it will run the Python operations. Okay? So virtual warehouses are your compute cluster. Now, Snowflake has two types of virtual warehouses. You'll you'll see these terms. You should not get confused. Standard warehouses and Snowpark optimized warehouses. We'll work with standard warehouses because Snowpark optimized primarily meant for huge data, AI and ML workloads. Okay? So data sets with very large memory requirements and for AI and ML, those use Snowpark optimized warehouses. Okay. Snowpark is Snowflake's feature, which allows you to write code in Java, Python, or Scala, okay, to build like ML workflows and other data applications. Again, we're not working with Snowpark, but you should know what it is. Why do you need virtual warehouses? If you're querying data, right, retrieving rows from tables and views, you'll need a virtual warehouse. If you're updating your data, if you're loading data into tables, if you're unloading data, right, all of this requires a virtual warehouse. Okay? Now, virtual warehouses come in different sizes. This is not very clear, but these are basically like extra small, small, medium, large, etc. And you know how many credits per hour these warehouses consume. Okay, how many credits per hour these warehouses consume. There are Gen 1 and Gen 2 warehouses. Gen 2 is most advanced one, better hardware, better features, better optimization. Okay? Gen 2 may not always be available. Right? Gen 2 is available in the region where I set up Snowflake, so we'll be using a Gen 2 warehouse, but really we'll be abstracted from the differences. We'll use those warehouses the same way. Okay. How much does your warehouse cost? It depends on how big your warehouse is and for how long it's running. Now, typically, a recommended best practice is you create a separate warehouse for loading your data. So you don't run your query processing and your data loading on the same warehouse. Now, data loading does not require a very powerful warehouse because data loading actually depends on how many files you're loading, how much data you're loading, and a more powerful warehouse, like a very, very powerful warehouse, typically does not help. This is Snowflake's recommendation. Okay? Now, a larger warehouse is more powerful, more compute nodes, right? More powerful nodes. Okay? Your queries will run faster if your warehouse is larger. Especially if you have very complex queries, it's better to have a larger warehouse. All right, actually, it's been 50 minutes. I've been talking and talking. How are things going so far? Any questions? Am I going too fast? Going too slow? Have things been useful so far? Have you understood everything? Thumbs up, thumbs down, happy face, sad face? Right, a bunch of thumbs ups. Awesome. So I'll keep going. By the way, we are almost at the top of the hour. I'll make sure to give you a 5 minutes break. I've not forgotten that. Okay. Warehouses are automatically suspended or resumed. Did I see sad faces? Yeah. If it's a sad face, please ask me a question. Okay. So virtual warehouses are automatically suspended or resumed. Okay. It's a group of compute nodes, right? We are abstracted from those nodes SB. Okay. HR, what should I repeat? What should I explain once again? Could you please tell me? Right. So virtual warehouses are automatically suspended or resumed only when they are running. Size of warehouses. HR, that will become clearer when we do the demos. Okay. It's a 1 day, 4 hour session. Okay. Query concurrency determined by size and complexity of queries. So how many queries can run in parallel depends on how complex your queries are, right? The more complex your queries, fewer queries can run in parallel. Now, if your warehouse is completely occupied in running queries, any new query that comes in will get queued. Okay. Any new query that comes in will get queued. Okay. Yes, multi-cluster warehouses are auto-scalable. Okay. Multi-cluster warehouses are auto-scalable. Okay. So basically, with multi-cluster warehouses, you can say I want between 1 and 5 clusters, and it will automatically scale based on the number of queries it's processing. PP, there is no way to say I want these many nodes. The only thing that you configure is the size of the warehouse. Larger the size, more the number of nodes. How many nodes are in there? That is Snowflake's proprietary information. Okay. Multi-cluster warehouses are auto scalable. Regular warehouses are not auto scalable. Okay. Is there a way to get to know how much? There are monitoring tools. Yes, there are monitoring tools. Yes. So cluster here just refers to the number of compute resources. So multi-cluster auto warehouses are auto-scalable. Regular warehouses are not auto-scalable. Okay. I hope I answered all the questions that came in. If I've not, please ask me that question again. Okay. So with multi-cluster warehouses, if many queries have come in, it will start up new clusters and run multiple clusters. If the load is less, it will shut down clusters and run just one cluster. Okay? So if you have fluctuating workloads and very spiky workloads, you will configure a multi-cluster warehouse. Okay. Multi-cluster warehouses improve the concurrency for users and queries. So many users and many queries can run. But if you want a single query to run faster because you're running complex queries, you have to. So, multi cluster warehouses do not improve the performance of slow running queries. If a single query is running slowly, you should increase the size of your warehouse. So, in order to improve the performance of slow running queries, you need a larger warehouse. Okay. Your charge for a warehouse depending on size of the warehouse, number of clusters, time the warehouse is running. Okay. Compute resources. Okay. Queries scale linearly with warehouse size. Okay. If you have large size tables, they cost more to query. They need more processing power. If you do a lot of filtering, join operations, that also impacts processing. Okay. Use separate warehouses for data load versus compute. Okay. Use separate warehouses for data load versus compute. Okay. These are just some best practices for data loading. I'm not going to belabor the point. Don't load very large files like 100 GB. Each file between, have multiple compressed files, right? About 10 to 100 to 250 MB each file. That's a better practice if you want the data to load quickly. Okay. Use separate warehouses for data loading and compute. Data loading requires minimal resources, so warehouses can be small. Okay. All right. Let's take a 5-minute break because I don't want to go too late over the top of the hour. We'll come back, we'll quickly discuss Snowflake objects, and then we'll get to demos and stay on demos for a bit. I'll see you guys in 5 minutes. Hey guys, I'm back. And I hope you're back as well. All right, I've shared my screen once again. And while everyone was away, uh, I will try to demonstrate query performance with different type of warehouses and queries. I'll run a simple query on a small warehouse and a large warehouse so you can see the difference in performance, right? I will do that. Remind me when I come to the query optimization demo. Okay? When I come to the query optimization demo. Okay? Multiple cluster. So basically, multi-cluster warehouse is a type of warehouse. You'll see that when we come to the demos. Okay? NJ, the answer is no. Okay? The answer is no. You have to load it into Snowflake. You can't just point Snow. You have to load it into Snowflake, or you can point to that bucket and query from Snowflake, but you'll still be paying egress charges from S3. You won't pay any ingress charges into Snowflake. All right. Let's quickly understand Snowflake objects. Okay. So your organization will provision Snowflake accounts, right? Organization, your account lives within an organization. Within an account, you have users, roles, virtual warehouses, other account objects. An account object is a database, so you will create databases. Within databases, you have a logical container called a schema, okay? And all your tables, views, um, user-defined functions, stages. We'll see what stages are, right? Stored procedures. All of these live inside schemas. Okay? So we'll be focused on, within our account, we have databases. Within a database, we set up schemas, and then we set up our tables within schemas. Okay? Database is a logical collection of schemas. Schema belongs to a single database. Right? Schema is just a grouping of objects like tables, views, and other constructs. Okay? Whenever you want to access like a table, a view, or a stage, you have to specify its namespace, and the namespace is the name of the database plus the schema. Okay, for all your DB operations. All right, so let's get started. Uh, okay, so bunch of questions. So NJ, I answered your question. The answer is no. How can you implement CI/CD? So there are Snowflake commands. You can use a copy command to copy from an external source, and then you can run like a ELT operation to load data. See, CI/CD is for deploying an application, right? But I think you're talking about ELT and ETL. There are different ways. I'll show you. We won't do a full pipeline, but I'll show you dynamic tables which are used for ELT. Okay. HR says schema level object or database schema. See, database is just a container. Okay. Schema is a container as well within a database. Okay. Your tables contain the data. How will you identify? They are very clearly demarcated in Snowflake. So let's, I think many of your questions, do you have procedures and functions? Yes. Yes. But I'm not focusing on those because those are very SQL related. I'm trying to show you Snowflake and focus less on SQL. So I've created a worksheet, if you remember. So let's go to our worksheets. I have this queries worksheet that I had created earlier. Okay. Let's take a look at the databases that we have. So I can run the show databases command. Okay. Now, notice that right now, I don't have any database selected. Okay. And I have some old data warehouse selected. This doesn't even exist. Let me just select this Snowflake Learning Warehouse. And this gray dot tells me it's in the suspended state. This gray dot tells me it's not running. So I can run the show databases command. How do I run this command? I place my cursor and I hit command enter or control enter. Okay. Place your cursor on the command and hit control enter, command enter. Okay. So here you can see there is a date. These are the databases that Snowflake set up by default. This is a database that I had created earlier. So by databases, you can see my database explorer over here. Okay. Now the show databases command, my virtual warehouse is still suspended. It's still suspended. That's because this is like a metadata query, right? So now I'm going to use one database. So I can say use database Snowflake sample data. So this database contains many sample tables. So within a database, we have schemas. These are all schemas. And within schemas, we have tables. Okay. So you can see that this is this Snowflake sample data is a database with many tables. So I'm going to use this. So I'm running this. Okay. And now notice that the database that's selected is Snowflake sample data. Okay. And once I'm inside a database, I can run the show tables command to see what tables are present in the database. So these are all the tables present in the Snowflake sample data database. So all the tables under every schema. Yes. So you can see that the schema name is different. So the tables are under different schemas. Okay. Now let's run a very simple. So I'm still running using the Snowflake Learning Warehouse. Now, as soon as you run a query that requires the warehouse, so I'm selecting star. This is the name of a schema. This is the name of a table, and this is my database. So when I query a table, it has to know which database your table belongs to, which schema your data belongs to. Okay? This is my database. Okay, this is my schema, and this is my table. This Snowflake sample data is my database. My schema is tpchsf1 here, and under tables I'm querying the customer table. Okay? So let's run this query. Now this table, you can see it has, it's pretty reasonably big, 150,000 records, right? But the query ran in 7.5 milliseconds. And as soon as I ran a SQL query, my warehouse is no longer in the suspended state. Oh, it is still suspended. You know why it's suspended? Because this query was cached. So let me run a different query. Let's query the part database. Yep, query took 1.3 seconds. Okay, 1.3 seconds. And now my Snowflake Learning Warehouse has the green dot showing that it's running. Hit refresh. You can see it started. You can see that it started. Okay. So PP, so basically, these are all topics beyond this course, right? This is an introductory course to SQL. Yes, there'll be Snowflake is not a place where you deploy like applications. You can build applications in Snowflake. How do we control access to database objects? There is identity and access management. You can set up users and roles, right? Again, beyond this course. Okay. How do we know that the output of the query comes from cache or from DB table? This is an excellent question, and this is exactly what I was going to answer next. So let's go to our queries. I said that, oh, this query, use the warehouse. So first of all, when you query from storage and not from cache, the warehouse is needed. The warehouse needs to be running. Okay. How do I know whether a query comes from cache or the warehouse? Okay. For cache or the storage, go to monitoring, go to query history. Okay. Okay. Notice that this particular query had compilation, provisioning, and execution. Notice that this query basically did not have any provisioning. So this query is from cache. Another way to know whether a query is from cache is by looking at the query profile. How do you see that? Query profile. When you see query result reuse, this means the query comes from cache. So let's go back. Let's go to a query profile of this guy. Notice it comes, there is a table scan. There is a table scan. Okay. The table scan means the query comes from storage. Okay. SL, I'll answer your question in a bit. Okay. So the query profile tells you how the query was executed. How the query was executed. Was it executed? And the query profile will come, we'll look at the query profile in a lot of detail in the optimization demo. It gives us a lot of information about the query. Gives us a lot of information about the query. Okay. Yeah. All right. Let's, are people clear on how to figure out whether the query results were served from cache or from storage? Okay. Now, I'll just show you this. Go back to our query. If we run this query again, so remember, notice this query took 1.3 seconds. If I run this query again, okay, it just took 91 milliseconds to run. Okay. And if I look at the query profile of this query, which I ran again, it tells me query result reuse. This is where the query is taken from cache. Now, billing difference. Remember your build if your virtual warehouse is running. If it's running. And if it's from cache, it's not processing anything. Right? But if it's running, you're still paying for the virtual warehouse. So there's a nuance there. All right, I saw a lot of thumbs ups. I'll see if there are any questions. Okay. So SN bucket refers to a cloud concept. It has nothing to do with Snowflake. Okay. Snowflake likely uses bucket under the hood, but we don't care about that. A cluster is just a cluster of compute nodes. Virtual warehouse is just a cluster of compute nodes. A database is just a logical container within which you have schemas, within which you have tables. Okay. SB, the answer to your question is no. It will it will refresh the cache. 24 hours in cache. No settings to change the cache configuration. Sorry, I'm answering the questions quickly so that we can at least move ahead with the demos. Right? Please tell me, I mean, if you're getting annoyed with my very quick answers, please let me know. But I'm worried that now we won't finish everything we want to, right? Okay. Now, how do you know what warehouse, what schema you're currently using? You can either look here or you can run this very simple query. It'll tell you your current warehouse, your current database, and whether you're in a current schema. There's no current schema. Okay. Right now I have no schema selected, but I can select a schema if I want to. If I select a particular schema, here I've selected a database and a schema. Okay. My suggestion is don't get too hung up on the small details. Focus on the big picture. Okay. See, the cache is actually in the warehouse. You're paying for the warehouse running. You're paying for the warehouse running. If your warehouse is running, you'll pay for it. If it's suspended, you won't pay for it. Right? NJ, that is in response to your question. Okay. All right. Now let's go to compute. We have our warehouse running. Okay. Let's create a warehouse. Oh, by the way, here under cost management, we can go look at our warehouse activity. Go to organization overview, select the Snowflake learning warehouse, and you can kind of see the query activity in this warehouse. Okay, accumulated monthly spend. Okay, everything was spent in September. All right, so let's go back to our queries. And okay, I said let's create a warehouse. Let's create our first warehouse. I'm going to call it my warehouse. So now when you create a warehouse, you specify standard, Gen 1, Gen 2, or Snowpark optimized. We don't need Snowpark optimized. We're not doing any big data ML. Let's just use a Gen 2 warehouse. Okay. Next, you pick the size of the warehouse. Now, remember, you can't control the number of nodes in your cluster, but you can control the size of your warehouse. And for our demos, we just use extra small, right? Now there are advanced options. Somebody asked about how does the warehouse turn off. By default, auto resume and auto suspend is turned on. Okay, auto resume and auto suspend is turned on. And by default, if you don't run any queries for 5 minutes, your warehouse will go into the suspended state and you don't pay for it. Okay, so your warehouse will go into the suspended state and you do not pay for it. So you can uncheck these, and then your warehouse, you'll have to manually suspend it and run it each time you're running a query. So it's best practice. Please leave auto suspend and auto resume checked. That's why it's automatically checked by default. Okay. Now this is a simple warehouse. a simple warehouse does not have auto scaling capabilities. It's just a static size, right? I've set it to extra small, it will remain extra small, right? But auto scaling comes with multi cluster warehouses. So you can say, I want minimum one cluster. Okay. Great question, PG. The answer is no. Okay. You set your warehouse size here. Okay. And then choose multi cluster. So you can say, I want a maximum of four clusters. Okay. I want a maximum of four clusters. Okay. You can turn on query acceleration. This is a special engine that Snowflake has to make certain queries run faster. So you can click on learn more and see what queries runs faster. Queries run faster. This query. So basically, these are the queries that run faster. Certain select queries, insert queries, create table as select queries, they run faster with query acceleration. Okay. We don't need query acceleration. I don't want a multi-cluster server. There is a scaling policy. Standard standard scaling will create new clusters as soon as it sees that your warehouse is kind of occupied. Okay. Economy scaling will wait for your warehouse to be fully occupied, and okay, for 6 minutes your warehouse is occupied, let me spin up like a new cluster. So it will be more stingy in spinning up new clusters. Standard will be less stingy in spinning up new clusters. Okay. I'm just going to create this warehouse. Okay. Now, a warehouse, when you create it, is automatically started. We can go back to our worksheet. Okay. So now I have two tabs here. Let's close this, close this, close this, close this. And now I can switch to using my warehouse. Right? See, now I'm using my warehouse. It's already running. And if you were to check, okay, you can run this. I'm running the same customer query. This will not retrieve from cache. Okay. No, stingy is not negative at all. It'll save you money. Not negative at all. So the customers table is a biggish table in TP CHSF 1000, and notice how long the query takes to run on my warehouse. Okay. HR, you have to tell me what you want me to explain again, because I keep talking. I have no idea. So AP, I think I answered your question. Yes, you can forcibly suspend compute. Actually, if I didn't answer my question, by the way, you can always go here. Okay. Scroll over to the right, click on the three dots, and say suspend, and suspend the warehouse. AP, that's in response to your question. Okay. HR, please ask questions, but I the thing is, I keep talking and I never know when the message came in. So what exactly you've not understood, I will not know, because there's also a lag. Okay. All right. You do not need to specify them in quotes unless they have like spaces or something. I just wanted to show you that this is also possible. Okay. Notice it's still running. It's taking 1 minute 22 seconds to run. Okay. And finally, after 1 minute and 23 seconds, I got my information. Okay. Now, if I were to run this query again, what do you think will happen? Okay. So the min and max is the number of clusters that it can scale to. It will start off with one cluster, and as more queries come in, it will add clusters to automatically scale up. That is response to you, HR. Okay. So here, okay, question for you guys. I'm going to run this query again. How long do you think it's going to take to run? Two answers. 1 second, 1 minute. What's the answer? I'm going to run this query again. Awesome, HR. That's right, SL. 1 second or 1 minute? Everyone says 1 second. Let's try. And I didn't even take a second. Exactly, it's in cache. So let's go to monitoring query history. The first time I ran this, look at how long it took to run. Okay. The first time I ran this, if you look at the query profile, look at how long the table scan took, right? Basically, it took forever. But the second time I ran this, query results reuse. Exactly CH. Okay. So let's go back to our worksheet. Okay. You should know that every query has a, it will, the cache will be, so I can't do this for this particular table, but the cache will be disabled. It will give you the latest data. You'll never get old data. Okay. All right. We have our data warehouse. We have our data warehouse. Let's now create a database, right? 24 hours. Query results are cached for 24 hours. Okay? Could be cached for longer, but they'll be cached for at least 24 hours. So let's create a database. Okay? So I'm going to catalog database explorer. And here, notice there's a plus database option. Okay? I'm going to create a database, plus database. And my database is going to be called IMDb. Okay? And it's going to contain some movies and directors information, and I hit create. Okay. And by the way, deleting a database is super easy. I had this test database that I created earlier. I can just say drop, and it will drop the database. Okay. And I can delete using SQL queries as well. I've created a database. Now let's create a table within this database. So I'll select this database, and you'll see that there are two schemas automatically created every time you create a database. You can create your own schema if you want to. So I can do plus schema here and create a schema, or I can just put my table in the public schema. Okay. I can put my table in the public schema. So I've selected the public schema and I'm going to click create, and it gives me everything I can create within the schema. So let's select table and let's select standard. Okay. And this will just show me an editor, and I can write a create table command here in the editor. Okay. I can write a create table command here in the editor. Simple create table, right? IMDb in the public schema, I want to create a table called movies. These are the columns in my table, like ID, title, budget. These are the column types. ID is not null, but the remaining can be null. Okay. The answer is yes, PM. Please be patient. We'll come to that demo. Okay. And I'm going to create this table. Oh, so now notice that for some reason it's using the wrong warehouse. Let's use my warehouse. Create warehouse. Did I say use the data load warehouse somewhere? Hmm. Create the data load warehouse. Let's just create the data load warehouse. I have no idea why this doesn't like this. My warehouse account admin, so let me run this again. No idea why it's trying to use a warehouse that I have deleted. So let's just cancel this. Let's go to my warehouse. I was going to create this warehouse anyway. So let's just delete this my warehouse, drop this, and create a separate warehouse for data load. Use option need to use. Oops. I created a Gen 1 warehouse, doesn't matter. Okay. Now I went back to catalog, database explorer, public, create table, not from file, create table standard plus database, create table, let's use the data load warehouse. Felt it's buggy. This thing is buggy for some reason. Now it's happy. That's the data load warehouse. And the movies table was created. You can see the table details. You can see the columns in the table. Okay. Copy history. This gives you a history of all any copies you've performed. You can run data quality and data profiling. We won't do all of that. And there is no preview of data because I've just created this table. That's right, SM. I could have used the use data warehouse command. That's right. I was going to create the data load warehouse anyway. I thought it's just easier, right? Okay. So now let's load data into this table. We can click on load data here. Okay. I have the movies table. I click on load data and I have a file here on my machine. Okay. I'm going to drag that file here. So in the IMDb public schema, in the movies table, I want to add the contents of this file, right? I hit next. It's using the data load warehouse for loading, which is what we want. Okay. So it's determined, it's figured out that it's a CSV file. Okay. Table loading append, that's fine. It's matching the headers in my file and it's matching them to my column names, right? I can change the mapping here if I want. It's giving me a preview of the data. It's not super happy with my rating field, it doesn't matter. And then it says, what happens if an error is encountered? There are several options. You can basically say, do not load any data. So just bail out of the load if there is an error, or only load valid data from the file. So we'll just say, don't load any data if there is an error, and there should be no error. And I'm using the data load warehouse for this. So let's go ahead and hit load. And once we load, we've got our table and we've got data in our table. Okay. So our data was successfully loaded and we can just say done. Okay. So here you can see a preview of the data once it's loaded. Okay. It's movie data. And if we go back to our worksheet, we should now be able to query this data. And by the way, you should be able to see the data here. Here is my IMDb database. In the public schema, under tables, I have my movies. And of course, now we can do our. Okay. What do you think is going to happen when I run this? Look at all the configuration in my worksheet and tell me what's going to happen when I run this command. Does anyone want to take a shot at figuring out what happens? Do we need to clear cache as well? No, we can't clear the cache. You can extract data from two schemas. Yes. It will fail. Excellent, excellent. UP says, can you please respond to questions at a time every 5-7 minutes? I think I'm trying to answer questions almost as soon as they come. UP. And if I've not, please forgive me and just ask the question again. I may have just missed it. Yeah. If I've not answered your question within 5-7 minutes, it's because I haven't seen it because there were so many questions or I missed it somewhere, right? That's the only reason. Yes, it will fail because I have everything wrong selected. So I need to select IMDb and I need to select the public schema and then I can run select star. Exact. No, table does not. Yeah, exactly. Table does not exist. Yes. So if I had the Snowflake no, sample data and this guy, right? And then I ran this, it'll basically tell me where's your table. Exactly. Yeah. You guys are spot on. Awesome. So here, now, if I do IMDb and public, I have the right database and schema selected. I can now run this query. No active warehouse selected. So let's select an active warehouse, Snowflake Learning Warehouse. So it needs a warehouse, it needs the right, but once you configure it, you can just run your queries. Yeah. So I've run my query. Let's create another table and we perform our joins, etc. There's a second table called directors, contains name, ID, and gender. Okay. I've run the create table command. And then we can load data into this table. So you can hit refresh here and notice the directors table is here. Let's go to catalog, database explorer, select the table. Right? Let's load data into this table. I have a directors.csv file that I'm dragging onto here. We go next. And we load data. It's figured out all the options are correct. Let's just load data in. Done. And here's a preview of the directors. Okay. So we'll go back to our worksheet and quickly make sure that we can query this. Select star from. Yeah. So all set, we successfully loaded data into two tables. Okay. Now let's run a few queries. Okay. Simple queries. We done select star from. Snowflake has some cool features with queries. So I'll do a select star from movies. Okay. Let's close this guy. Okay. Now, PG, the answer is yes. The answer is yes. So if you just have public, select the schema. So PG says, can we directly just load a file without creating a table first? And the answer is yes. So if you go to Database Explorer, select your schema, and you can just say create table from file. Okay. VT, that's just the format of this data set, right? There is no metadata data set. I think the gender is just 1 and 2, right? Or 0, 1, 2. I can't remember. So that's just the format of the data set. That has nothing to do with Snowflake. Okay. So you can just say, so, all right. So let's go back to our sheets and we'll run this demo. We'll just focus on queries. So we've done select star from movies and let's close this and notice that let's select a few columns and you'll see some interesting stuff. I'm going to select the ratings column and notice that Snowflake, I'm trying to see if I can expand this. Can't. Notice Snowflake gives you a nice little histogram of the distribution of ratings. Right? It gives you a nice histogram of the distribution of ratings. Okay? Can't you load data from cloud databases directly? The answer is yes, UP. You can load data. So for example, you can say if you go to ingestion and add data. I'll just go here. Ingestion, add data. You can basically, there are many connectors available. There are many connectors available. I'll show you how you can access data from an S3 bucket later on, one of the last demos, right? But we are not looking at these connectors today. But I'll show you how to access data. We'll do the S3, not from here, but via queries. Okay, so notice when I select ratings, it gives me a nice distribution and I can filter as well. So let's say I want the very top rated I can just select this bar, and by selecting it, it's giving me the two movies rated 10. Or I can select this bar. So it's giving me the movies rated between 6 and 7. So you can perform these cool filtering operations right within your query results. Okay, right within your query results. Then let's select budget. So let's clear filter, select budget, and this is a distribution of the budget. And you can select these, and your data will be filtered based on the bucket that you selected. Based on the bucket that you selected. Okay? And it's super simple to build visualizations as well. Okay? Will this work only for number data? There are different things for great question. Let's look at categorical data, right? Let's look at title. Okay? It'll just tell you 100% filled. Let's look at date. It gives you a distribution for date. So it's not just numeric data, right? I don't have a data set. Maybe later on, if I use a data set which has a, oh, let's look at our directors, right? Let's look at select star from directors. By the way, it's case insensitive. You can write in any case you want. Okay. So I have gender. Yeah, it's not numeric. So with categorical data, you'll get a bar chart as well. Let's see, name. Yeah. If it's very high cardinality, like everything is very like different, it'll just tell you it's filled. Okay, let's see how we can do some visualizations. Very simple ones. So I'm performing a simple select from where query. Okay, let's run this. Okay. Let's plot this. You can create a chart. Okay, then you can say, you know what? So you can see there are not that many charts available. So I do feel that visualizations in Snowflake are not that powerful, right? So if you want to do visualizations and build dashboards, it's probably a good idea to connect like a BI tool, like a business intelligence tool, and then do that. So let's do bar chart. Okay, bar chart on, I want budget, not sum of budget, but I want budget, and on the on the x-axis, I want the release date is fine. Wait, why does it have this strange release date? Title. Yeah. So this is a simple bar chart. So on the y-axis, I have the budget, and on the x-axis, I have the title. There's some old movies data. Okay. So CH, for debugging SQL queries, you will use the query profile. Right? We won't do any debugging, but I'll show you how you can interpret the query profile when we do the optimization demo. Okay? That will come. We're still 2 demos away. I'll show you some cool things with querying dates. So this is a simple visualization. Now let's look at how you can query dates. So I've done a select star where release date between 1st January 2012 and 31st December 2012. So let me run this query. Control enter. Okay. So you can notice how you can run this in the where clause. But you can also dynamically configure dates. So you can use this date bucket function. And the minute you say date bucket, notice that my UI changes. So it's allowing me to specify my grouping. So I can say group by year. I can say group by year, hit apply, and notice it's giving me a count of movies by year. So date bucket gives me this dynamic UI, which allows me to, I can say group by month, hit apply, and now it will group by month. Okay. So what are the debugging options? I think I answered that. Basically, for SQL queries, we use the query profile. How can you run Python scripts for visualization? So if you want to visualize using Python, you will use Streamlit, right? If you go to projects, notice Streamlit. Streamlit is a way to use this Streamlit library. Right within Snowflake, you can write Python code to build dashboards and cool widgets and filters on your visualization. So you can visualize using like Seaborn, Matplotlib, etc. Can you rearrange the columns in the result set? No. No, you can't. Okay. All right. So there are some other cool options you can do with date. So you can basically say colon date range, and here it will give you a range of dates. So last 3 months, last 28 days, last 12 months. Okay. Let's say custom. Okay. Let's say custom. If you, okay, let's say I chose last 28 days and then I hit apply, I'll get no results because this data set is basically there's no data for the last 28 days. So let's say custom. If you say all time, then we'll just, this will give me all the data, right? But let's say custom and let's say Jan 1st. So let's go back all the way. Let's do it from here. 1st Jan. The reason I'm doing it from here is this is the fastest. 01/2016. Okay. To December 1st, 12/01/2016. So notice it's selected from 1st Jan 2016 to December 2016. I'll say done. I'll hit apply. And if you look at the dates, you can see it's between Jan and October 2016. So there were clearly no movies it has in November and December. Okay. No, this is for dates. This is for dates. It has some cool things you can do with dates. Okay. All right. So regular SQL queries work like standard SQL. So you can use the OR clause, for example. Right? Select star from directors where name is one of these three. Right? You get those results. You can use the okay, like command. You can go to the query profile here, and this shows you the query execution graph. We've seen this earlier. See, notice it does a table scan, it does a filter, and then it gives me the result. Okay. So for every query, you can view the profile. What if I do a join? Right? Here I select the title and the director's name, and I join the movies and directors on the director ID. So I join movies and directors on the director ID. Okay. And then I perform a filtering where director's name like Steven, and I order by director's name. So it's a slightly more complicated query, right? So let's go ahead, and I can also run my query from here, by the way. And let's look at the query profile. So you can see the join. Two tables were scanned. There was a filter and a join filter, then the join, and then a sort, and then the result. This is how you can debug your queries, because each of these, it'll see this table is very small, right? But if you're writing complex queries and you want to know where the bottleneck is, right, you can kind of click through each of these and you will get insights from your query, and you will get ideas on how you can improve the performance of your queries. Is there an AI coding assistant? So, sorry, under AI and ML, this Cortex, is there you can improve the performance of your queries. Is there an AI coding assistant? So, sorry, under AI and ML, this Cortex, is there AI features? The last I checked, there was no assistant, but it's been 3 4 months since I looked at their AI features. So it's quite possible there is a coding assistant. Good question. But clearly not for the queries, right? Clearly not for the queries. So this is my complex join query. And if I were to run the join again, and then I were to look at the query profile, it will just reuse the results. It just reuse the results. All right. How are things going so far? Thumbs up, thumbs down, happy face, sad face, any questions? Now I'm looking at the chat window and my Q&A. When I'm doing demos, I have to look at a little different window, so I have to keep looking back and forth. That's why I'm a little worried that I may miss questions. So please feel free to ask your question again. It's not my intention. Everyone seems happy, everyone seems to be following along. So shall we go on to the next demo then? Oh, actually, we need to do a little bit of theory, right? We have done the basics. Okay, let's do a poll. There's my poll. Awesome. Glad to see that everyone's following along. Okay, let's do a poll question. Not happy with the break duration. You want it to be shorter, CH? Since this is the middle of the class, I'm okay to do a 7 minute break. But that's about all we can afford. 10 minutes. No, no, no. CH, 10 minutes. I'll never finish everything. I'll do 7 minutes. Let's compromise between my 5 minutes and your 10 minutes. Okay, I have a poll question for you guys. HR, could you please use the poll widget to respond? Please do not respond on chat. Uh, you, it's behind the media player. It's behind the media player. I'll just wait a few more seconds as I see. All right, let's take a look. And those who said independently scale compute and storage, you guys are absolutely right. The 3 layer architecture gives you independent storage and compute. Let's keep this poll and let's move on. Table structures in Snowflake. Okay, let's understand how tables work in Snowflake, and then that will also give us time travel. Now, when you're working with big data, okay, when you're working with big data, the tables are not a monolithic object. Okay, the tables are not a monolithic object. So let's use Xcal, my favorite Xcalid draw. Okay. Okay. So when you're working with large data, okay, your tables are not monolithic. Okay. So it's not like your table data is stored in this way, and consider this to be very large data. Now, why does this not work? Let's say I'm running a query on this table. My query has to scan the entire table, and I lose any parallelism that I might have got, right? If I had split up the data. So with very large data sets, your data is usually split into segments. Split into segments. The data is split into segments. So this will contain like the first, I don't know, X GB of your data. Then this will contain some. When queries run on your data, let's say you're running a filter operation, it will run parallel queries. One query will run on this segment, a second query will run on this segment, a third query will run on this segment. The results are then collated together and then returned to you. So this is referred to as partitioning your data. This is referred to as partitioning your data. So when you query big data, when queries are run on tables that are huge, terabytes or petabytes, queries will run slowly. There is no parallelism in query processing, and the entire data needs to be scanned for each query. Okay. So better performance and scaling, you get better performance and scaling when you partition your tables. A partition is just a segment of your data. So it's common practice for all big data platforms when they store data, they actually split it into segments or partitions. And this helps parallelize queries, which means every query has just less data to scan. And this is what makes their performance like better. This is what improves their performance. Okay. So we'll talk about table structures in Snowflake when we get back. And since CH requested and I agree, it's 2 hours, let's do a 7 minute break. I'll see you guys back in 7 minutes, and then we'll talk about how tables are structured in Snowflake. Yeah. Guys, I'm back. I hope you're back as well. Let me share my screen once again. AN, basically, Snowflake will keep track of metadata to know where things lie. And when you run optimization, it'll keep track of additional metadata. Okay, that's how it knows where the requested data lies. But if you perform a general filter operation, it'll check all segments of data. Okay. Looks like everyone's back, or at least many of you are back. Let's talk about table structures in Snowflake, and let's talk about micro partitioning and clustering. Okay. Now, micro partitioning is done automatically. Okay. So all tables are divided into micro partitions. Basically, this drawing that I drew here. Okay. Now, why are they called micro partitions and not partitions? Because they tend to be pretty small, 50 MB to 500 MB of uncompressed data. That's why they're called micro partitions and not partitions, but they are just partitions or segments. So these are contiguous units of storage which contain 50 to 500 MB of data. So you take a very large table and you chop it up into these very small partitions. Okay? And here is the answer to your question. Snowflake stores metadata for each micro partition. For example, it will store the range of values for each column in every micro partition, the number of unique values in a column, okay? And a bunch of other properties. They don't tell us what properties they store, but they store a bunch of other properties for optimization and query processing. So this is how it will prune your queries. It will not look at, let's say you're querying a particular range of values and that's likely to be present in 5 micro partitions. It won't look at the other 200 micro partitions. Let's say you have 205 micro partitions total, right? So it will use the metadata to run your queries in a very, very optimal manner. In a very optimal manner. Okay. Now, micro partitioning is automatic. It's not something you can control. It's not something that you can turn off, right? When we have stored, like whatever table we have stored, it has been divided into micro partitions. Okay. The size of the micro partition is measured in uncompressed data, but the data is stored compressed. This is in response to your question, AN. The size of the micro partition is measured in uncompressed data, but the data is compressed. Okay. Okay, so micro partitioning is automatic, no manual intervention from you, fine grained pruning. So you like the pruning is because the partitions are so small, it's much more granular, right? Every partition is more or less the same size, so your data will not be skewed. Queries run in parallel on micro partitions, okay? And because it's columnar storage, only the columns you specified in your query will be scanned. The other columns will not be scanned. Okay. Okay. Now, clustering is something which is not automatic, but something that you have to explicitly perform on tables. Okay. Clustering is where your data is stored along natural dimensions. Now, how does that help? So let's go back to our Excalibur draw here. Okay. Let's say, actually no, I have a nice visualization for clustering. I just remember. Let's say that you have data from different countries, sales data from different countries, okay, running to millions of records. And it's common practice for you to query data by country, right? Where country equal to Japan, country equal to India, country equal to I don't know, Germany, right? It's common practice for you to query in that manner. If you cluster your data by country, if you cluster your data by country, it will basically bring all data for the same country in contiguous memory location. So it will reorder your data. So all data for the cluster column, in our case it's country, will be in contiguous memory locations. Okay. So once you find like a record for Germany, you will just continuously read the data in contiguous memory locations for Germany. Okay. So clustering is where data is sorted. So it sorts your whole table along natural dimensions. Okay. And then of course your data is still micro partition. Your data is still micro partition. Okay. And then you have clustering metadata for each micro partition. Oh, this micro partition has Germany's data. This micro partition has Japan's data. This micro partition has US's data, and so on. Okay. And it'll also like kind of see, oh, how many is US data spread across multiple micro partitions, right? Things like that. So it'll see overlapping micro partitions. So clustering is great if to optimize range and equality predicates. Range queries are any query where you use like the less than and greater than sign. Equality predicates are where you use the equal to sign. Natural dimensions is like country, state, city, category, right? A dimension that's present in the data. Okay? SP, that's in response to your question. Okay. So SN, see how it's competitive with other tools. I will do a quick comparison of Snowflake and Databricks a little bit later on, right? But I'm not going to compare Snowflake with every other tool that's out there. Uh, as for concepts of Snowflake, these are the fundamental concepts, and I have to teach you theory before I can do demos, right? That's just the nature of the game. Can clustering be applied? So there are some catches, but most of the time we work with standard tables and you can apply clustering to those. So there are all kinds of different tables in Snowflake. We won't go into the theory of those. Whether clustering can be applied or not, I'll have to look up the docs as well. But yes, you're right that clustering may not be applicable to all tables. So this is clustering. So here is an example of a table that is not clustered. So there is a country column. Now let's say I were to cluster by country. This is how the data would be applied. This is how the data would look. This is how the data. BG, the answer is no. So BG has a question which says, is micro partition equivalent to range partition, list partition, or hash partition in RDBMSs like Oracle? The answer is no. Micro partition is just basically taking the bulk of your data and just chopping it up. Right? It's just chopping up your data. Okay? So this is how your data will be organized when you have a clustered table. And then of course this will be broken into segments, right? It will be chopped up into segments. Another optimization technique is called so clustering is an optimization technique that you apply on your data. Okay. Another optimization technique that you can apply is search optimization. Search optimization is basically creates a data structure like an index. Okay. It's applied to all columns of the table usually. It creates an additional data structure which contains where your data is stored. Okay. So let's say this is your table. Let's say this is your table. Okay. Search optimization will kind of create another it's like a B tree like data structure. Okay. Sorry, my tree is really horrible. But that kind of points to different parts of your data. Okay. So when you query for a particular record for equality predicates, like when ID equal to A or ID equal to B, okay, it will use this kind of tree structure, the search optimization data structure, to look up the data in your table. So lookup is very, very fast. Okay. So that is so it improves the performance of selective point lookup queries. That is search optimization. Okay. So search optimization, there is a separate data structure. So that obviously takes up space, so that will cost you a little more, right? But you don't have to reorganize your table. SN has a question: what do we do with Snowflake? You query and analyze big data, you build visualizations, you can run ELT processes, you can uh, basically query and analyze big data. That's the big thing. And you can do ML, AI, you can build apps on top of your data. Okay. So as your data is updated, your the search optimization data structure will also be updated. Next, let's quickly talk about the different types of data and then we'll go back to our demos. Okay. Now, there are three types of data Snowflake stores. There's active data, that is the data that is current in your database, right? That is active data. That's the data that we are actively querying. There is time travel data. Time travel, so active data is data that can be actively queried. Okay. So all your SQL queries, your data definition language, your data manipulation language, all of these run on active data. Time travel data is the basically data from the past. How your table looked 1 minute ago, or 5 minutes ago, or yesterday, or a week ago, or 15 days ago. Right? Time travel means you can query data from the past, data that has since been updated or deleted, but the past data is still accessible. You can create clones of tables, schemas, and databases from the past. If you dropped a table, you can restore it. Somebody had asked a question about this. I had quickly answered and said yes. Basically, if you drop a table, if it is within your configured time travel period, you can restore that table from the past. You can restore that table from the past. Okay? And then finally, even after time travel, you have fail safe data. So time travel can be configured for a maximum of 90 days. Okay. Time travel does depend on the subscription plan. If you have the starter subscription, time travel is allowed only for 1 day. But for every other subscription, time travel is allowed for a maximum of 90 days. Maximum of 90 days. However, you can configure it to be lower if you want. Now, after the 90-day period, let's say you suddenly realize that you need access to the data. 90 days have passed by, and you suddenly realize, oh my God, I need access to this data. Okay? For 7 more days after the 90-day period, okay, your data is still recoverable by Snowflake. So you'll have to kind of mail Snowflake and tell Snowflake that, oh, you know what? I'm sorry, my time travel period is done, but I still need this data. And in a few hours or a few days, Snowflake will give you that data. It's not automatic to get it from failsafe. That is failsafe. Okay. No user operations allowed. Data recovery may take hours or days. Snowflake makes best effort to retrieve data. Okay. Snowflake supports three main types of tables: permanent, temporary, transient. There are other types of tables like dynamic tables that I'll discuss separately. Okay. Basically, these tables differ by how long they persist, the time travel you can configure, and the fail safe period. I don't think this is very difficult, so I won't go through it in detail. Temporary tables are only for the session. Sorry. Transient tables exist till they're explicitly dropped. Okay. And you can see that standard edition tables, permanent tables are, they have only time travel up to 1 day, but all other permanent tables up to 90 days configurable. There's also something known as external tables. Let's say you have data in S3, Azure Data Lake, or Google Cloud Storage. You can create an external table, point to that data. Your data will continue to remain in the external storage, but you can query it from within Snowflake. So there are only read operations allowed for this. That makes sense. Query and join operations are allowed. Okay. All right. So time to go back to hands-on demos. Yeah, hands-on demos. Any questions? Everything good so far? How are charges applied to time travel and fail-safe? Time travel is basically, remember, your data is backed up, you're paying storage charges. You're paying storage charges. What's the difference between a transient table and a permanent table? Here, transient table is basically no fail safe, okay, and it has only 1 day time travel. Permanent table, for most editions, 90 days of travel and 7 days of fail safe. This is the difference. The difference is all in this table that I have here. Okay. Where do you configure the type of table? When you create the table, you use this keyword temporary or transient. Okay. I'm not showing you how to create those tables. It's very straightforward. You just use the keyword temporary or transient while creating the table. Okay. And one second, FR is absolutely correct. I read that micro partitions in tables mutable, write data when a record is modified. Yes. So the likely how Snowflake writes data is they make use of like kind of write logs. So they'll keep a version of, they'll create another kind of version of the table. That's why time travel is possible. They're immutable because time travel is possible. Okay. That's in response to your question, SB. All right. Shall we move on to the demos? Everyone, thumbs up, thumbs down. If it's thumbs down, please ask me a question. Time travel and SnowSQL. Now, in order to do SnowSQL, I need my. Everyone okay? Happy face, thumbs ups. Everyone still awake? I know 2 hours are done. What's the benefit of using transient table? The time travel of 1 day will mean less data is stored, and it'll cost you less. Awesome. So let's keep going. And the next thing we'll do is time travel. Okay. So we'll continue working with our movies table. Okay. Now, time travel can be for a maximum of 90 days. Okay. Time travel can be for a maximum of 90 days. Okay. So I've created a table called movies 2017, and I've tried to configure time travel for 100 days. Okay. If I do this, it tells me no, I can't do this. Okay. Now, if I do not want time travel for a particular table, I can set my data retention to be 0. I can set my data retention to be 0. Okay. Movies 2017 has been created. Okay. And then I'm going to create another table called movies 2016. Okay. Same columns. Okay. But this has a time travel period of 5 days. So all the changes that I have made to my table over the last 5 days will be available for me to query. Okay, will be available. So both of these tables have been created. Let's take a look at these tables. Okay, and here, notice here is my retention period. Here is my retention period. Okay? 5 days for movies 2016, 0 days for 2017. Okay, so let's now insert some data into the movies 2016 table. Okay? So I'll select star from the original movies table between this release date, and I'll insert some data into the movies 2016 table. Okay? So 104 records have been inserted. Okay? Now let's see how time travel works. Now, time travel can use timestamps or query IDs. So the first thing is it uses UTC as UTC as the time zone. So I'm going to set the time zone for the current session to be in UTC. Okay, that was executed, and let's get the current timestamp. So you can run a get date function to get the current timestamp. So here is the timestamp. I'm going to copy this. Okay, and I'm just storing it as a comment. So after loading the movies 2016 table, I have this is my current timestamp. Okay. So this is after loading the 2016 table with 104 records. So let's track that. Okay. Now let's actively change something in that table. Delete from movies 2016 where budget is less than 100,000. Okay. So it's deleted 18 records. So my current live table should have 104 minus 18, 86 records. Okay. Now this deletion operation, this is the deletion operation. This deletion operation has a query ID and I lost that query ID. So let's get it. Let's get the query ID of this deletion operation. The way I can get it is I can go to monitoring query history. Here's my delete operation. Here are the query details. I'm going to copy the query ID over and I'm going to paste it. Here I'm commenting it out. Okay. After deletion of 18 records. So with 86 records in the table. Okay. So now the current number of records in this table is 86. Okay. We've seen this. All right. So here, this is how I time travel. So before statement, so before I ran this delete statement, what was my data? So I'm basically running this command, okay, before this statement was executed. So before this statement was executed, which means I should have 104 records in this table, and you can see I have 104 records in this table. Did this make sense? I just want to pause here to make sure I've not lost anybody. Everyone still with me? This is an example of time travel using statements. So you have a bunch of IDs, you want to look at data before you ran a particular query, you can do this. The latest table still has the deleted records. Excellent. So everyone's understood. Okay. You can do this for timestamp as well. You can do this for timestamp as well. So here, okay, can you insert the see, we don't have access to the deleted records anywhere, right? What we can do is run a query, okay? We can run a select star from the original movie, from the historical movies, how did the commit happen? As soon as I execute the query, things get committed. This is not transactional, right? As soon as I execute the query, things get committed. This is in response to USM. Why equal or greater than sign? No, this is just greater than or you can just say greater than. It needs this. This is just a way for it to say before this statement. This is a part of the syntax. It's not the equal to greater than sign. It's a part of the syntax. Is there a command like git to see all of the commit history? I don't think so. Let me just think for a moment. I believe there is a command in Databricks has this. Hmm, Actually, good question. I let me just quickly look this up. SB, whatever question you asked, because now I'm getting confused between Databricks and Snowflake. Okay. MS, yes, you can truncate the current table and reload from history. Okay. So now you can do this based on timestamp. So this is my the timestamp that I had copied. Okay. So select count star at timestamp. So you can do before at. Okay. So 104. Or you can give an offset. Okay. Or offset. So you can say this is 60 seconds into 5. So 60 seconds multiplied by 5. So that's 5 minutes. So select the data in movies 2016 as it existed 5 minutes ago. And there were 104 records 5 minutes ago. I'll just pause here while you look at these three commands. Okay. How to check all the changes? Uh, NS, what changes do you want to check? See, the query history will show you all the queries that you have run, but just all the queries that you've run. Yes, that's correct. It's a, I don't know if it's a SM. Yes. Let me just make sure I'm answering the right person's question. Okay. Is there any command like git to see all the commit history? SP, I think the answer is no. I don't know if there is like a describe history command. I know um, no, you can see the query history, okay, but you cannot see the um, like what are the operations on this particular command. If we did 5 changes, can we see all the changes? No, you cannot see. That's exactly what I'm saying. There's no way to kind of just run a describe history and see. It's a very good question. I'm actually looking to see whether they've added it. The last I knew they don't, but I'm now, I feel this is important enough that I should check whether they've added it, and I don't think they have. Yeah. So, all good questions, you can't do this. Okay, let me just show. So, if these basics of time travel are clear, let me just show you that now my 2016 table has time travel enabled. So, I can drop the table. Let's say I drop the table, that is deleted the table. Okay. Let's verify that it's dropped by running a select star. Okay. I can undrop the table. undrop the table, okay? And then I can run this select star and it's back. It's back. Okay? But if I drop this table does not have time travel enabled. So I cannot undrop this table. See, did not exist or was purged. That brings us to the end of our time travel demo. The next demo we'll do SnowSQL. SnowSQL. So Snowflake has a command line interface. Let me know if you can see my terminal window. Can you see my terminal window? Yeah. Snowflake has a same the time travel retention period. In our table, we had configured it to 5 days. Does it apply to databases as well? Yes. Yes. You can't see my terminal window? Okay. Let me stop sharing. Yeah. Uh, no, can't see it. Okay. Stop sharing. I'm going to share. How do I share my entire screen? Okay. Here. Now you should be able to see my. So, yeah. Okay. SB, the way you would do that is you would truncate the table and then copy from the older version back into your uh, back into your table. You'll insert from the older version back into your table. Okay. So now you can see I've shared my screen. Okay. Now first let me show you how you SnowSQL is very useful if you want to run scripting commands, right? So let's go here. Okay. How do you install SnowSQL? Okay. There is an installer. So SnowSQL on Microsoft. Yeah. So there is an installer, and you can use if you go to the SnowSQL download page, this is the SnowSQL download page, right? And here you can install SnowSQL for Linux, Mac OS, or Windows. Okay? Now I had Mac OS, so I just went here, downloaded the installer, clicked through the windows, just followed whatever they said on screen, and SnowSQL was installed. Okay? And I have SnowSQL installed already because I didn't want to waste time going through the installation in a live course, right? We have limited time. I didn't want to waste that time doing an install. Okay? So I have not a very recent, maybe from last year version of SnowSQL installed on this machine. Okay? If you were to install now, I think you'll get version 1.4. Okay? Now, I have a directory called SnowSQL working directory, and I'm going to work within that directory. Now, how do I connect to my Snowflake account using SnowSQL? This is the command that I run. And then now you'll ask me, how did I magically get this command? Right? That's a good question. -u specifies the username, whatever username you sign up for. So when you activate your SnowSQL account, this is the username. Now, how did I get this? This is my account identifier. So here, you can go here. Let's open this up. Here I am. So go to account and say view account details. Okay. Notice here is my username, Looney user. Okay. And here is my account identifier. I just copied this. Okay. I just copied this. And I specify my username and account identifier and I hit enter. And now I can't remember my password. So I'll have to go find that. Because this is a trial account. Yeah, it's asking me for a password. Okay, I found my password. And I am in SnowSQL. So I'm logged in as Looney user. It's using the data load warehouse. Okay, you can easily change the warehouse and no database. So if you want to specify which database you want to use, you can say use IMDb. So now it's Looney user using the data load warehouse, IMDb, and the public schema. So you can say use warehouse, use warehouse, Snowflake learning warehouse, and semicolon. Okay. So you can run the usual commands here, but of course, the Snowflake UI is so much nicer. Okay. And how do you clear things? You run system clear, exclamation mark system clear. These are system commands, okay, that will clear the screen for you. Then what else can you run? Simple select. You can run your select commands, right? If you want to see a history of queries run, you can say bang and queries. So this gives you like I think 25 queries, the last 25 queries that you ran. Okay. And then you can hit up to get the previous commands, just like what you would do in a command prompt. You can set something called variable substitution to true and use variables in your queries. Okay. So I'm going to define a variable called first name. I've set the first name to Adam. Okay. And then select star from directors where name like ampersand, first name, percent. So this indicates that it's a variable. So it will take Adam and then any last name. Percent will match any last name. So it will give me all directors whose name starts with Adam. Okay. If variable substitution is false, okay, if variable substitution is false, then the same query that we ran earlier will not work. Right? Here, when variable substitution is set to true, it knows that first name is a variable once you've defined it. Okay? Where's variable substitution to true? I set it back to true. Let's run system clear. Okay. You can also do like it supports partial variables. So here's a partial variable. You have to use curly braces then. Okay. Ampersand indicates it's a variable. Okay. Within curly braces, first name partial, then I can specify a specific last name. So remember, first name was Alan, first name partial is Alan. So here it found Alan Alda. If you want to see all the variables that you have set, these are the variables that I've set. And these are some variables that it set by itself. Okay. And if you want to exit from SnowSQL, you hit quit and semicolon. I'm not going to exit, but this is how you exit. Okay. We'll come back to using SnowSQL uh, to upload data from our local machine. All right, that finishes SnowSQL and we can do optimization. So we'll make sure we finish optimization before the break. For sure, I think we'll finish. Can we use regular expressions with the SF? SF meaning the command line. So you can use regular expressions as in like. There are some limitations, like the percent was like how you use it in like commands, those. But it doesn't support like the full range of regular expressions. Is it bind variable. Uh, BG, I'm not sure I understood your question. All right. So this was just the next demo is I think the most interesting one. Okay? And I promise somebody I'll show them how a query runs faster on a larger warehouse. So I'll make sure to include that. Okay? So if you're good, we can move on to the next demo. So let me first show you how a query runs faster on a larger warehouse. So for that, we'll use the Snowflake sample data and let's find uh, a large table. PPSF 100, customer has, okay, yeah, customer is fairly large. I think, have we already queried this? Uh, Catalog sales, oh, too large. I don't want it to be so large that it's spending all its time running. Let's look at TPSF 1000. Okay. Oh my god. 6 billion rows, orders. Okay, these are, I don't want them to be so ginormous. I just want the right size. Okay. Let's, what we'll do is we'll run one of these. The TPSF 1000 customer one, I think, is the safest. Okay. Let's place name and enter. Okay. And we run it on the data load warehouse. Okay. The data load warehouse. So normally we are not supposed to run queries on the data load warehouse, but I'll just do it here because data is not cached in the data load warehouse. So I'm going to first run this query on this extra small warehouse. Then we'll create a bigger warehouse, okay, and then run the same query on that. Remember, when data is cached, it's cached in the warehouse. It's cached in the warehouse. So if you switch warehouses, you don't have the same caching. So you don't have the same caching. So let me run this query on the data load warehouse. Let's just run it and let it take its time to run. Okay. So as it's running, let's go to compute and create a larger warehouse. Plus warehouse, standard, so let's create a medium, let's create a large warehouse. So I call this large wedge. Okay. And we leave everything else the same. So here it's still executing 25 seconds. Okay. I'm now going to run this query on the larger warehouse. So let's go here, let's go to everyone following along what I'm trying to do. If you've not, please let me know. I'm going to run the same query, but why? Why not? Oh, it's not letting me run it because it's already running a query. We'll have to wait for it to run. So meanwhile, I can ask you, do you guys have any questions? Are you following along so far? Everything good? Oh, you know what? I know how I can run. Let's create a new session. Now it will let me run. And now I'm going to run it on the large warehouse. Okay. This session has a query running. Yeah, run it on new window. Exactly. BT, thank you. You can cancel the query here, but let's not cancel it. Let's see how long it takes, right? So no database selected, that's fine because I've specified my full path. I'm using the large warehouse. Let's run it on the large warehouse. Let's see if it runs faster. This guy is still running. It's like 1 minute and 51 seconds. Okay. I could cancel the query. If it runs for too long, we'll cancel it. Oh, here it comes. 1 minute and 55 seconds and 16 seconds. Right? Larger the warehouse, faster your queries run. For concurrent queries, use multi-cluster warehouses. So if you want to support more complex queries, use a larger warehouse. If you want to support a large number of users, use a multi-cluster warehouse. Okay. Clear? Whoever asked me the original question, sorry, I can't remember your initials now. But I told you I'll do it when I come to the query optimization demo. I remember that. Okay. So now let's do the query optimization demo. Okay. From the Snowflake sample data, okay, I have this part sub table. Let's just take a look at that table. Why doesn't it like part sub? Does the table not exist? Just flaky. So this is how the data looks. It has some, it's sample data, right? It has some gibberish stuff inside. But this is how the data looks, right? Just for our knowledge. Now, I'm going to show you two optimizations, clustering and search optimization. So I'm going to create two tables, one that I plan to cluster and one that I plan to add search optimization to. If you remember, clustering sorts the data so that by whatever your cluster column is, so that records with the same value in that cluster column are located in contiguous memory locations. And search optimization creates an extra data structure. So I'm going to, right now, I have not clustered or run set up search optimization. I'm only going to create, let's just put it in the IMDb database. Okay. Let's just put it in the IMDb database. Okay. So I have not clustered or turned on search optimization yet. I have not. I will, right? But I haven't done it yet. Okay. Cluster table created, search optimized. Let me just create the table. Okay. Both tables have been created. Now let me turn on clustering and search optimization. So I'm cluster by supplier key. Okay. Now you will cluster by the column that you use the most often in your uh, filter queries, in your where clause. So cluster by the column that you use the most often in your where clause. Okay. So let's say I query by the supplier key all the time. So I'm going to turn on clustering. So clustering was executed and I'm going to run search optimization. Okay. So let's look at our path sub tables. Okay. Clustered, search optimized. So cluster by, it's clustered by supplier key. Okay. And clustering is on for the first table. Search optimization is on for the second table. Now, search optimization progress so shows 0 because remember, search optimization, it has to build a data structure which gives you quick access to the records in your table. It has to build a data structure. So it's taking some time. It's not that big. It should be done in a minute. So now if you look at search optimization, it should say 100%. So now we have a cluster table and we have a search optimized table. Okay. So now I'm going to run a number of queries. Okay. And just close all of these windows. Okay. This is the original table. This is my clustered table. And this is my search optimized table. This table is not clustered, not search optimized. Okay. Not clustered, not search optimized. And we will look at the query profiles of every run. So I'm going to run this. Okay. It took about 1.5 seconds to run. See, now I wouldn't pay so much attention to the seconds because this data is very small, right? I did not want to use something that takes 2-3 minutes to run, because each time I run a query, it'll take 2-3 minutes, right? So let's look at the query profile of the first one. Okay. Now the most important thing is when you look at the table scan operation, when you look at the table scan, okay, you can see there are a total of 237 partitions in my table. These are the micro partitions. Okay. And in order to give me my result, 230 of them had to be scanned. Right? I queried based on that part sub supplier key. There are 237 partitions and 230 had to be scanned. So clearly a lot of data had to be read to give me my response, to give me my result. Okay. Now let's do it for a clustered table. For a clustered table, I'm going to say view query profile. Okay. And let's look at the table scan. And here there are 177 partitions. So it's just kind of set up the table a little differently. And only one partition was scanned to give me the result. And that's why it ran so quickly. So out of 177 partitions, only one was read to give me my results. And let's see our search optimized table. Okay, can't tell anything from the seconds. Let's look at the partition scan. And you can see search optimization access. Out of 173 partitions, only 69 were scanned and 101 were pruned. So here clustering was clearly the best. Okay. So remember, the most expensive operation is reading the data, because it has to be read from disk if it's not in cache. Okay. It has to be read from disk if it's not in cache. Okay. So this is the difference between clustering and now let's look at a different kind of query. Okay. Now let's say I were, so remember I've clustered this on the supplier key. Okay. On the supplier key column. I've clustered this on the supplier key column. So if I query by PS part key, I'm not going to get any benefit. Okay. How do you decide which method is better? Remember, search optimization is usually on all columns. If you're going to query by different columns, use search optimization. If you're mostly querying on a single column, choose clustering. If you're going to do range queries, choose clustering. If you're going to do point lookup queries, do search optimization. So I did this. Let's look at the query profile. I'll give you a summary at the end. Okay. All partitions had to be scanned because I filtered on a different, see, I clustered by supplier key and I filtered on part key. So it can't use the clustering. So all partitions had to be scanned. But for search optimization, remember I turned on search optimization on all columns. So if I run this, I look at the query profile, it made you a search optimization and only one partition was scanned. Only one partition was scanned. Okay. Did everyone understand the difference? We'll take a break in like 1 minute. I have the last part of this demo and then we'll take a break. Okay. But I just want to ask you, do you understand the difference between range queries and point lookup queries? This is an example of a range query. This is an example of a range query. A point lookup query has the equal to. Right? Queries equal to, where you usually, that's a point lookup query. With an equal to an, equal to. If you have an equal to, that's a point lookup query. A range query has a greater than, equal to, less than, equal to. Okay? Now, if you're going to perform range queries, you should use clustering. So let me show you that. So this is the original table. Let me run this. I'll just close all of these windows we had. Okay. Let's look at the query profile for the original query, and almost all partitions would have been scanned. Yeah. So 230 out of 237 partitions were scanned for this range query. In a clustered table, clustering is very good for range queries. Clustering is very good for range queries. You look at the partition scan, you can see the green check mark showing that it was optimized. Only 19 out of 177 partitions were scanned. Search optimization does not work for range queries. Search optimization does not help with range queries. You look at the query profile, notice it doesn't have the green check mark, and 170 out of 173 partitions were scanned. So, range queries on one or two columns equal to cluster. Point lookup queries on any column, search optimization. Was this clear? It's time for our break. If you have any questions, ask me during the break and I'll respond to it once we are back. So let's do our 7-minute break again so that CH doesn't get mad at me. See you in 7. Just get pushed out. Hey guys, I'm back. I hope you're back as well. Let me share my screen. Next, we'll look at views and dynamic tables. So first views and then dynamic tables. So before we do that, I'll do a quick overview of the difference between Snowflake and Databricks. So you should understand that Snowflake and Databricks started at around the same time, I would say 2013 to 2015. Okay. And they started at very different ends of the spectrum. So Databricks is a it's not public yet. It's still I guess a private company, and it was started by the developers of Apache Spark, the big data processing system. So basically, what they did is they built their whole platform. Both of them are data platforms. Both of them are supposed to help you. Both of them help you process and analyze your data. Okay? However, Databricks started off with more coding centric view. So it was basically users of Apache Spark. It was basically to help you make use of Spark in a more intuitive and easy way. That's where Databricks started. Whereas Snowflake started with a data analyst point of view, help you to make you run SQL queries very, very easily on huge data sets, right? However, they started at two ends of the spectrum, and apparently their CEOs were great friends, but they started moving towards the center of the spectrum, and each started doing what the other was doing. Snowflake started offering like machine learning and analytics and AI, and then Databricks started offering queries and visualizations and time travel and all of those things. And now there's a lot of overlap. Okay, so Databricks and Snowflake are competitors. So Databricks is a cloud-based data platform just like Snowflake, meant for processing and analyzing big data. But Databricks is primarily powered by Apache Spark. By Apache Spark. Databricks allows you to run SQL queries on your data, perform data science and engineering operations by giving you access to Python code and Python notebooks, right? And recently, Snowflake 1 year ago introduced notebooks. And Databricks has an entire machine learning platform that allows you to build and train machine learning models and manage the whole life cycle of models. So I feel Databricks is much more for the data scientist, whereas Snowflake is much more optimized for the data analyst. And um so that's the kind of like big picture difference, but really you can do the same thing in both. You can do the same thing in both. So Databricks makes use of a storage system called Delta Lake, which powers what they call their data lakehouse platform. It uses a Spark engine for data processing. It has machine learning environments where you can build and train models in TensorFlow, Scikit-learn, PyTorch, and you primarily write code in notebooks, right? But it has a SQL editor as well. So both of them, this is how they're exactly the same. Both are managed data platforms. Both are integrated with the three major cloud providers, right? Azure, AWS, and Google. They have decoupled storage and processing layers, and they're highly scalable. How are they different? Snowflake is SQL based. SQL is its primary offering. You can write code in Python and R, but SQL is its primary offering. Okay. Databricks, you can write SQL, but kind of processing with Apache Spark ended up being its primary offering. Okay. So data processing with Snowpark within Snowflake, Spark, right? Snowflake is actually much better at batch processing. Databricks has very good support for batch and streaming, and Databricks has excellent support for machine learning. I should add that to the slide. Databricks has excellent support for machine learning. Snowflake support for machine learning still in its early stages. Still in its early stages. All right, let's do one poll question just for a little break so I can ask you how things are going. Uh, does this work? Where's my poll? Yeah, one poll question, and then we'll move on and discuss views. So let's do a quick pulse check. How's everything going? Thumbs up, thumbs down. You following along? This is the last hour of the training. We'll try and do views, dynamic tables, and bulk loading of data for sure. And then I want to show you how we can query data from an external stage, but not sure we'll have time. Let's see. I'll try my best. See a bunch of thumbs ups. I'm glad. I'll just wait a few more seconds. All right. Let's take a look. And if you guys said backup, you're absolutely right. Active data, time travel, and fail safe are all three storage components. Yeah, are all three storage components. All right, let's quickly do views. Views shouldn't take very long. What is a view? It's basically a way, it's a query that produces a result which you can then query. Right? If you're familiar with views from databases, views in Snowflake are exactly the same. Okay? And views are very useful because they allow you to segregate or protect data. What does that mean? Let's say you have a table with sales data containing the sales information of all countries in the world in your organization. But you want the salespeople from India to access only the India sales data. You want the sales guys from Spain to access only Spain sales data. If you want the sales guys from the UK to access only UK's data, right? You can create different views on top of the same table, right? So you'll create views with create view India sales data where country equal to India, create view US sales data where country equal to the US, right? You'll create these views and then you'll give the different sales people access only to the view that they need, right? So you'll just protect the underlying data. That's a view. Now there are two types of views in Snowflake: non-materialized views, they are just regular views, and materialized views. Right? Non-materialized views do not store data. When you query a non-materialized view, it will run the query on the underlying table. When you query a materialized view, actually stores the data in a separate storage location. So it will store the subset of data that goes in the view in a separate storage location. Okay? And when you query the data, it will actually uh, query that separate storage location. Okay? So non-materialized is just the name definition of a query. The view's results are not stored for future use. Materialized views, the views query results are stored as though they were a table. Okay? So, for example, if you were to look at this here, okay, here is the underlying table. If you have a non-materialized view, every time you query this view, it will actually query the underlying table. If you have a materialized view, okay, this is I call this MV, okay, it will actually store data in this here. So when I query the view, I'll get the result from the view. Now, because the view only stores a subset of the data, but when you query a materialized view, it actually runs faster. Your query runs faster. Okay? But you have to pay extra for storage space. Storage results take up additional space. Okay? Both materialized and non-materialized views can be secure. Secure views basically prevent knowledge of the underlying table. I'll show you this in the demo. You'll see how they're different. So let's materialized views are promptly updated when your data is refreshed. So if your underlying data changes, the materialized view is updated. Great question, Ian. Materialized views are always up to date. You can actually configure them to with a lag. You can configure them with a lag as well, but they're always kept up to date. Okay. So here I'm creating a regular view from my movies data. Okay. So create or replace view. When I just say view, it's a regular view. Okay. Now, when I run a select star from this view, I'm going to run a select. Wait. I run this properly. Okay, created. Now, when I run a select star from this view, it's actually querying the underlying table. It's actually querying the underlying table. So how do I know this? I can bring up the query profile. Remember, the query profile is a very useful way of debugging what's going on. Notice that when I query the view, it's actually querying the underlying table, both tables. Okay? Now let me create a materialized view. Okay? Oh, actually, let's do a secure view first. So I'm going to create a secure view. Now, in this regular view, notice we could see what, so when you looked at the query profile, right, you can actually see what table it's scanning. You can see what table it's scanning. Okay? I'm now creating a secure view, and the only difference here is I call it secure view. Okay? I'm now creating a secure view, okay? And then I'll run the secure view. And how do I know it's secure? When you look at the query profile, it won't tell you anything about the underlying table. This is useful if you're sharing the view with somebody else. So let's say I'm the administrator, I create the view and then I share it with other users. With an insecure view, they may be able to see the details of the underlying table. But with a secure view, they'll never get access to the underlying table. Okay? So let's, I have a, okay. I'm going to run a, I'll show you the difference between regular and materialized views now. So remember, this is a very large table. When I run a count star, you can see that I think there's 100 million records. Okay? I'm going to create a regular view and a materialized view. So this is a regular view for younger customers, and by younger I mean anyone born after 1985. Okay. So I've created the view, and I'm going to run a query on the view. Okay. I'm going to run a query on the view. Okay. Yes, caching works for both. For normal view, non-material. So for a normal view, the data is cached because you're querying the table. Okay. For a materialized view, the data is just cached in a general view. The cache concept exists. So great question. So now when I do a select star from younger customers and I look at the query profile, you can see that it's scanning the original table and you can see that it's scanning all 221 partitions. Okay. And it's basically scanning 3.36 gigabytes. Okay. Now I'm going to create a materialized. Okay. I'm going to create a materialized. Okay. It'll take longer to create because it's actually storing the data in a separate storage space. It's taking longer because of that. But once it's saved, now when I query the materialized view, it'll run much faster. It will run much faster, and more importantly, we look at how much data was scanned. Let's look at the query profile. And if you look at how much data was scanned, only 345 MB. So all 24 partitions in the view were scanned. Okay. Great question. Clustering or search optimizations cannot be applied to a view because in a regular view, no data is stored, right? Okay. Right? Clustering or search optimization is not applied to a view. Okay. So it's not applied to a regular view. Materialized views are just like tables. You can apply them to materialized views. Secure views done. Let's not do, I did the demos. Any questions on views? Materialized versus non-materialized? Sorry. Clustering and I just said clustering and search optimization are not applied to views. They are not applied to regular views. They can be applied to materialized views. So great question, Ian. Yes. Awesome question. Can a materialized view have a time travel option? This is a great question. I need to look this up. But I believe the answer is so the thing is actually the answer is no, because logically, if you think about it, a materialized view, you can't update the materialized view. You have to update the underlying table. So time travel will be enabled on the underlying table and you'll automatically get it on the view. Does that make sense, SN? Cool. All right. Let's do dynamic tables. Dynamic tables are a very, very cool concept. They are a very cool concept. Okay. A view from an optimized table takes the same. Yes, yes, yes. Uh, Not a materialized view, but a regular view takes advantage of the optimizations in the table. So, again, a very good question. You guys are asking great questions, right? Awesome. You're making me think for every question. It's not an easy answer. All right, let's do dynamic tables. Dynamic tables are like a super cool concept. Okay. Basically, let's say you want to build ELT pipelines, right? So ELT pipelines, right? Where you extract data, you put it into Snowflake, okay? And then maybe you perform some more transformations and you put it in another table, then you perform some more transformations, put it in another table. You can automate this entire process without writing any code by building dynamic tables. Okay. Dynamic tables are basically tables that automatically refresh based on a schedule, based on a defined query. So you create a dynamic table by querying an original table, okay? And you specify a target freshness. So you'll say refresh from the original table every 1 minute or every 5 minutes. So the data in the dynamic table, let's say you say 5 minutes, will be never more than 5 minutes older than the data in the original table. Okay? And then you can apply whatever transformations you want on the original table to get your dynamic table. So you're basically building a pipeline of data transformations in a completely automated way. Once you create the dynamic table, you're done, right? So let's say these are your original base tables. Okay. You can even have a dynamic table as a base table. Okay? Then you can create dynamic table A, which is some result of querying the base table A and B. And then dynamic table B is some result of querying the base table B and C. And you can set like a target freshness and say, query, make sure you're up to date every 5 minutes or every 1 hour or every 2 hours. Right? So when your base table is updated, let's say your target freshness is 1 hour, within one, at exactly like the 1 hour mark, your dynamic table will be updated. Okay. So dynamic tables are great for automated management of data dependencies and refresh schedules. Basically, it will automatically update your data. You don't need very fine grained controls. You can't like configure very small things, but you can set a target freshness and make sure that the data in your dynamic table is no older than that target freshness. Okay. So how do you initialize dynamic tables? You can initialize them on create or on a schedule. Okay. So if you initialize them on create, as soon as the table is created, the dynamic table will be refreshed from the original base table. Okay. And then it will keep refreshing based on the dynamic table. With materialized views, you are not setting a target freshness. You are not setting a target freshness. Will there be a cost incurred? See, there'll be the cost of running the queries, right? There's a cost for running the queries because the queries will have to run on a data warehouse, right? You're not going to get the queries are not going to run for free. They'll run on a data warehouse. That's the cost incurred. Okay. Target lag, the target lag or the target freshness, it specifies how outdated the data in a dynamic table can be. Okay. So if you said 5 minutes, your table can only be 5 minutes older than the base table. The data can only be 5 minutes older, or the data can only be 10 minutes older. This is something you configure. Okay. You can have the data, you can use auto refresh, incremental refresh, or full refresh. Auto will use incremental refresh by default, meaning only the changes in your table will be refreshed, only the changes. Okay. Incremental is again changes, but you can specify full refresh as well. You can specify full refresh as well. I'll just keep this, just let me know if you understood auto, incremental, and full. Okay. So with a full refresh, the entire dynamic table will be recalculated from the original table. So that's a very heavy duty operation. Right? So ideally, we want incremental refresh, and with auto, it will try to do incremental refresh unless it can't. So it'll kind of use its brains. So this is actually best understood in a hands-on way. All right. So I'm going to create a new database and create a table within that database. So a database called SalesDB. I'm going to use that database and I'm going to create a table called source sales. Okay. So let's refresh. Yeah, I have my sales team. Let's insert some data into the source table to start off with. The source table is the base table. Okay. Auto or incremental. Auto is preferred because auto will kind of try to make the right choice, right? But if you're very sure that you don't want to do a full refresh, just go with increment. So I've inserted 5 records into the source sales table. Okay. Now I'm going to create a dynamic table. Okay. I just call it dynamic table. It's total, and now I perform an aggregation to populate this table. Total sales by category. Okay. Target lag 1 minute. So my dynamic tables data will be no more than 1 minute older than my source tables data. Okay. I'll use the Snowflake, what's it called? Snowflake Learning Warehouse. I think that's what the warehouse is called, right? Snowflake Learning WH. I'll use the Snowflake. Refresh mode is auto. I'll initialize the table when it's created. Okay. And this is the query for this dynamic table. So I want for a category. Okay. And I want to do sum of amount. Now, for this particular aggregation, incremental refresh will not work. Incremental refresh. That's why I say auto, it will automatically do full refresh. This is important. For this particular query, incremental refresh will not work. So I'm going to run this. This will create a dynamic table. They moved where the dynamic table is. So let's look at the database explorer, sales DB, public. Come on. Tables and dynamic tables. Yeah. You can see it's a dynamic table. It's got that little lightning icon there, and it tells you like what query is used for the dynamic table. Okay. And you can see table details. You can see refresh history. Okay. It has been refreshed exactly once. Exactly once. Okay. For some reason, it shows maximum lag is 7 hours, 19 minutes. I have no idea why. Target lag is 1 minute. Yeah. Okay. Refresh. Okay. All right. So let's keep this open, this refresh page open, and then I'll go back to the queries here. Can you create views from dynamic tables? I believe you can create regular views. I'll look that up for sure later. Okay. So let's just make sure that we have the data in our dynamic table. Okay. Select total sales by category. Yeah. So note this 50, 450, 80. Just keep this in mind. Okay. Keep this information in mind. Let's see if I can paste this. Yeah. Okay. Now I'm going to insert some data into my source sales table. I've inserted a few more records into my source table. Let's go and sit at refresh history. Let's do this. I'm, I'm not selected. Okay. So So look at only what's on September 16th here. Okay. Look at only what's on September 16th here. Let's refresh. Okay. So notice a refresh ran at 9:02 and then a refresh ran at 9:03. And now I'm going to run the same query once again. Select star from total sales category. And you can see we have updated values. My dynamic table was automatically updated when I inserted new data into my source table. I'm going to insert more data into my source table in the fitness and home decor. So I've added two new categories. I've inserted more data. Let's go check our refresh. Within a minute, we should refresh. So 9:04, I think it refreshed almost immediately. It was time for a refresh. Okay, 9:04, I think it should have new data. And is the data updated? Not yet. Not yet. So this refresh didn't catch my 9:04. Yeah, here's a second refresh. Now the data would have updated. Yeah, five categories. So I updated the source table. The dynamic table was automatically updated. A materialized view will automatically update. Will automatically update. With a dynamic table, you specify a target lag. Okay. This is the difference between a materialized view and a dynamic table. It's a great question. Okay. With a dynamic table, you can actually chain them up like this. You can actually chain them up like this. You can have base table, then one dynamic table, then another dynamic table, right? Whereas you don't chain up materialized views like that. Dynamic tables are usually used for like transformations. You will transform the original data in some way. And then you specify a refresh mode and so on. Materialized views are just a way to expose a subset of data to people. Dynamic tables are for ELT pipelines. BG, I hope that answered your questions. Very good question. It's also used for replication. Hmm. See, you could, you could. But the replication is not really needed because Snowflake is not supposed to lose your data. Okay? Snowflake is not supposed to lose your data, right? So Snowflake is automatically replicating data under the hood. Materialized views will improve latency. Correct. That's not the objective of dynamic tables. Correct. So this is absolutely spot on. Can you create views from dynamic tables? The answer is yes. 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 All right. Shall we move on to our last topic of the day? Unfortunately, we only have time to discuss normal stages and we won't have time to load data from an external system. But like I said, I have the demos in the GitHub link that I had shared earlier on in this course. You can do the demos. The demos are self-explanatory. If you've gotten this far with me, the demos are self-explanatory. Shall we move on? I'll just pause for a minute. I mean, it's awesome. You guys are asking so many questions that I feel that you're getting a clearer understanding of everything that I've covered rather than just covering a breadth of topics. So I'm glad. Uh, Dynamic table is like tables using with condition. No, dynamic tables is like used to build a pipeline in an automated fashion. Okay? It can be an intermediate table as well. So I see a bunch of thumbs up. So I feel like everyone's following along. No, this is a one session class. There is no session tomorrow. Yeah. This is a one session class. Okay. All right. Let's quick, no, sampling. We don't have time for all this. We are going straight to the next important thing, stages. Data loading in Snowflake. This involves stages. A stage is just a Snowflake. All these technologies love fancy words. A stage is just a fancy word that refers to where data files are located in cloud storage. That's it. Okay? That's just a fancy word. There are two types of stages, external stage and internal stage. Okay? External stage means your data sits somewhere else, like S3 or Azure or Google Cloud. Okay? And you just query that data, or you can load that data by accessing that external stage. Internal stage is within your Snowflake account. An internal stage is within your Snowflake account. Okay? And Snowflake supports three types of internal stages. They really make things confusing. Just remember this, they support three types of internal stages: user stage, table stage, named stage. Okay? A user stage is basically, see, I've logged into Snowflake with my user account. A user stage is a special location where I can store my own files. Okay. And once I've stored my files in that stage, I can load it into any table. Okay. User stage means it's my own stage associated with my user account, and I can load those files into any table. Okay. Into any table. A table stage. Every table that you create in Snowflake has its own associated stage. So if you go to Excalidraw, a user stage is associated with a person, right? Associated with a person, okay? And data from the user stage can go into any table, okay? A table stage, a table stage is associated with a table. So data from a table stage can only go into one table, the table that it's associated with. Okay? The third kind of stage is a name stage. This is a special stage that you create. Just like we create tables, we create views, you can create a name stage, and data from a name stage can go into any table. Okay? So just remember this. It's very confusing, but that's what I have here in words. Table stage, user stage, and table stages are implicit. These two are implicit. Implicit meaning you don't have to create them, they just exist. Why are stages needed? Great question. Basically, if you're bulk loading data into Snowflake, you'll put your file into a stage and then from a stage, load it into a table. You know how we uploaded data from the UI directly? That's only possible for us if your data size is small. I think it's like 50 MB or 100 MB. If you have larger data, right, in gigabytes and petabytes or multiple files, you need to put the files in a stage and then load from the stage into uh, into tables. That's why stages are needed. So the user stage and the table stage are implicit, meaning you don't have to create them, but this has to be created. Name stages have to be created. Okay, that's all I've talked. Let's just do the demo. Things will become much clearer. So this demo, please tell me you can see my screen, terminal window. Okay. So now I'm going to, now when I want to work with data on my local machine, I forgot what it's called, system clear. So, I, yes, I saw a bunch of thumbs up. Okay, so I'm creating a new database called organization, and I'm going to use the organization database. Okay, and I'm going to use the data load warehouse. All right. So now I open up a new tab. Oh, not a new window, a new tab. Open new tab. In this directory, I have this UK customer CSV file. Okay, I am going to put it into my user stage. How do I do this? I go here, put, I need to, I use the put command. Okay, put full path to the file and ampersand tilde access is the user stage. Okay, so AN, it applies to all kinds of data, applies to all kinds of data, and this is how it helps in data loading. Okay. So I put the file from my local machine into my user stage. Okay. So this file has been copied and put into my user stage. Okay. And now I can list my user stage. It'll show me, okay, yeah, actually this file was not copied because I was working with this. I can remove this. Let me do the remove first. So I can say, I feel I can use the rm command, right? Yeah. Let me just get rid of this and let me run the put command again. And now it will take the file from my local machine and it will put it in my stage. The put command can only be run from SnowSQL because SnowSQL has access to your local directory structure. The Snowflake UI running on the cloud does not. Okay. So the file has been uploaded and then I can list the contents and you can see that this file, so this is like a folder that was created and then this is my gzip file. Okay. Now in the Snowflake UI, I go back to the Snowflake UI, I go back to my queries. Okay. And let's create a new table called customers. Okay. And let's copy from my stage into this customers table. Okay. Now, when I run this, this is going to result in an error. Okay. Because there is one column which has some invalid value, one row. So you can simply say on error continue and it will skip over those invalid rows and still load data. So out of 4015 rows or 4014 were loaded, it was the header row that was a problem. Okay, the header row was a problem. And now I can run select star from customers and the data has been loaded. Customers does not exist because I have to switch to organization. So this is how I bulk loaded data from a user stage. Okay. Yes, UP has a very important point. It costs money for you to keep files in a stage. It's storage costs. Excellent point, UP. Okay. Select star from customers. Now, notice here that there is one problem with this. Notice how my white collar, blue collar has the quotes. Okay. So let's delete the data. Truncate table customers will delete the data from customers. And you can basically specify the file format where you say type a CSV, field delimiters, comma, skip the header one, and my fields can be enclosed using quotes. If you run it like this, it will run without error. So all four, so it skipped the header, right? So the error header did not give an error, and it will have taken care of the quotes properly. So now my blue collar, white collar shows up correctly. Data in my user stage can be loaded into any table. So I'm going to create a same table called account holders, and I'm going to load the same data into using the copy into command into account holders, and I can do it. So this symbol is for the user stage. At the rate tilde. This at the rate tilde is for the user stage. Now let's load data. Now, even though I've loaded data into my table, if I run a list command on my user stage, the data is still present there. The data doesn't disappear. So now I'm paying twice for the data. I should delete this if I don't want to pay twice. Okay. All right. So let's delete the data in both tables for now, because now I'm going to show you the table stage. The table stage. Okay. The table stage has the same name as the table, and it has the prefix ampersand, sorry, at the rate percent, just to make your life very difficult. So if I list this, okay, yeah, so there is no file here in my table stage. Can it hold duplicate data? Yes, you can. You can put the file with the same name twice, but if it has a different name and the data is a duplicate, yes, it can hold that. Okay. If there's an error for loading few rows, where do I get the log and find those errors? There is a command for that. If you run this after you get the error, if you run this command, oh, if you load the same file twice, great question. You should be able to. Let's try that in the table stage. This select query that I've given is for UP. This is how you see what the errors are. So let's now load data into our table stage system. It's really annoying to write system here. Okay. So what was I doing? So I'll put my file into my table stage. I'm at the rate percent name of table. Okay. Now let's list it and make sure it's there. Yeah, it's there. Okay. And then we can run the copy into command from here, but let me just go to SnowSQL and let's copy into the customer stage. So from the table stage into the customer table. Okay. And let's run the same copy again. It knows it's the same file. If the file had a different name, then it would load it in. So once it has loaded the file, it keeps track of it. So SS had a great question. SS, did this answer your question? And did everyone else understand SS's question? See, if I try to load from the stage again, it'll say not present. But let me try and load from my stage. This I have not tried. From the user stage custom. It loaded the data. See, when the duplicate data is in the same stage, it won't load it. But I loaded the duplicate data from different stages and it had no idea it was a duplicate. So it's kind of using metadata on the stage to track what's going on. It's using metadata on the stage to track what's going on. Yes, you can have as many files as you want in the table stage. Yes. And the files are in a gzip format. Somebody asked me that question. Okay. Now, you cannot load into, from the customer stage, you cannot load into the account holders table. So from this table stage, you cannot load into a different table. It will not allow you. It will not allow you. It will not allow you. All right. The last one is a named stage. So let's just delete all the data in customers and account holders. Okay. For a name stage, its name stage is like a database object. So I've created a stage called customers data stage. Okay, I've successfully created the stage. Okay. And if you actually run show stages, you'll be able to see this. Okay. You see the customers data stage is present here. Now, recently, let's go to catalog, no, organization, public, tables and stages. Name stages are listed here. Name stages are listed in your database explorer. This is important. And recently, you can actually add files from here. But I think there is a limit. Yeah, see, 250 MB. So you can add files to stages using the UI, but there is a limit. And that's why SnowSQL has no such limit. SnowSQL has no such limit. So I am going to put the file from my local working directory into my name stage in a folder called stage customers. Okay. You can run a list command on this to make sure the data is there. Yes, it is. Okay. And then in SnowSQL, we'll run okay, data was loaded. Notice I didn't have to specify the file format because when I created the stage, I specified the file format there. So then when I do the copy into, I need not specify the file format. And from a name stage, I can copy into any table. I can copy into the account holders table as well. All right. That's all we have time for today. I wish I could have shown you querying data from an external stage. Let me see how big it is. Uh, we can do it really quickly if we go 1 minute over time. So let me just go to AWS because I'll just show you what I already have. I already have some data here. I already have an S3 bucket. I've set those up. And the S3 bucket is Looney Snowflake source bucket. And then I have the historical data sets folder here with some data. Okay. So let's go to over here, create a new database. Okay. Now I'm going to create a stage which points to this S3 bucket, but I need AWS credentials for this. How do I get these credentials? On AWS, you can go to Identity and Access Management. Okay. Go to users. I already have a user created, but you can just create a user here. Okay. The main thing you have to do is give the user permissions to access buckets. So you need to give the user Amazon S3 access. Actually, you can give them more granular permissions to only read buckets, but I've given full access. It's just easier for me, right? And then go to security credentials, create an access key. Okay. Next, create access key, and that will give you an access key and a secret. Just copy these over. Access key ID, I copied them over here. Secret, I copied that here. Now these credentials have access to AWS. I've created a stage, okay, called store data stage, S3 store data stage, and that just points to an S3 bucket. This URL is what makes this an external stage. Okay. And if I'm able to list the contents of this stage, that means my credentials are working as expected. Credentials are working as expected. And I can, of course, list the contents of just historical data sets. Okay. To access Snowflake, no, I'm actually running on Azure. I'm running on Azure. I'm running on Azure. The credentials, the credentials that I created is what is giving my Azure account access to the S3 bucket. Okay. And now I'm going to create a file format to indicate the kind of file that I'm working it called CSV format. And I can query the data in the external stage. So the data is in S3, I'm querying it from Snowflake. Okay. Yeah, data is in S3, I'm querying it from Snowflake. I haven't yet created a table. How to know on which cloud platform? Go to here. So you can see the little icon here, and if you look at view account details, I'm sure it will have some information. Here, Azure, cloud platform, Azure. Yeah. All right, we are 1 minute past the hour. So I'm going to stop here. I hope you guys enjoyed this course. Thank you for being such a great set of learners. So many questions really made me think. And I had a lot of fun. I hope you did as well. And please do fill out the survey for this course. It will help me kind of know how to structure this course from here on in. So that feedback will be super useful. Thank you very much. I hope you had a good time. Have a good evening, morning. Thank you, NS. I'm glad you liked it. Thank you, FR. Thank you, everyone. UP, they can. Azure accounts can load data from the Google Cloud. All right, Ellen, I think we can close out the course.
All right. Well, thank you, Janani. Thank you to everyone who participated in today's course. We hope you enjoyed it and benefited from it, and enjoy the rest of your day.